Welcome to the DevOps Crash Course, where we will make understanding of DevOps easy and fun. DevOps, short for development and operations, is like the secret sauce of modern software development. It's all about making things fun, smooth, and efficient. In this course, we will cover the basics like what DevOps actually is and why it's super cool. We'll also talk about how much money DevOps engineers can make, which is pretty impressive. But the real fun begins when we dive into the tools. You'll get to know the 9 awesome DevOps tools. From Git and GitHub for version control to Selenium for automated testing, Jenkins for continuous integration, Docker for containerization, and Kubernetes for orchestration. We'll cover it all. Join us as we unravel the intricacies of this DevOps crash course, laying the foundation for a successful career in the world of software development and operations. Get ready to embark on exciting learning now.
We're going to go through a number of key elements today. The first two will be reviewing models that you're already probably using for delivering solutions into your company. And the most popular one is Waterfall, followed by Agile. Then we'll look at DevOps and how DevOps differs from the two models and how it also borrows and leverages the best of those models. We'll go through each of the phases that are used in typical DevOps delivery, and then the tools used within those phases to really improve the efficiencies within DevOps. Finally, we'll summarize the advantages that DevOps brings to you and your teams. So let's go through Waterfall. So Waterfall is a traditional delivery model that's been used for many decades for delivering solutions, not just IT solutions and digital solutions, but even way before that. It has its history that goes back to World War II. So Waterfall is a model that is used to capture requirements and then cascade each key deliverable through a series of different stage gates that is used for building out the solution. So let's take you through each of those stage gates. The first that you may have done is requirements analysis. And this is where you sit down with the actual client and you understand specifically what they actually do and what they're looking for in the software that you're going to build. And then from that requirements analysis, you'll build out a project plan so you have an understanding of what the level of work is needed to be able to be successful in delivering the solution. After that, you've got your plan, then you start doing the development, and that means that the programmers start coding out their solution. They build out their applications, they build out the websites, and this can take weeks or even months to actually do all the work. When you've done your coding and development, then you send it to another group that does testing, and they'll do full regression testing of your application against the systems and databases that integrate with your application. You'll test it against the actual code, you'll do manual testing, you do UI testing. And then after you've delivered the solution, you go into maintenance mode, which is just kind of making sure that the application keeps working. If there's any security risks, that you address those security risks. The problem you have, though, is that there are some challenges, however, that you have with the waterfall model. The cascading deliveries and those complete and separated stage gates means that it's very difficult for any new requirements from the client to be integrated into the project. So if a client comes back and the project has been running for 6 months and they've gone, hey, we need to change something, that means that we have to almost restart the whole project. It's very expensive and it's very time consuming. Also, if you spend weeks and months away from your client and you deliver a solution that they are only just going to see after you spend a lot of time working on it, they could be pointing out things that are in the actual final application that they don't want or are not implemented correctly or lead to just general unhappiness. The challenge you then have is if you want to add back in the client's feedback to restart the whole waterfall cycle again. So the client will come back to you with a list of changes, and then you go back and you have to start your programming, and you have to then start your testing process again, and just you're really adding in lots of additional time into the project. So using the waterfall model, companies have soon come to realize that the clients just aren't able to get their feedback in quickly, effectively. It's very expensive to make changes once the teams have started working. And the requirement in today's digital world is that solutions simply must be delivered faster. And this has led for a specific change in Agile. And we start implementing the Agile model. So the Agile model allows programmers to create prototypes and get those prototypes to the client with the requirements faster. And the client is able to then send the requirements back to the programmer with feedback. This allows us to create what we call a feedback loop, where we're able to get information to the client and the client can get back to the development team much faster. Typically, when we're actually going through this process, we're looking at the engagement cycle being about 2 weeks. And so it's much faster than the traditional waterfall approach. And so we can look at each feedback loop as comprising of 4 key elements. We have the planning, where we actually sit down with the client and understand what they're looking for. We then have coding and testing, that is building out the code and the solution that is needed for the client. And then we review with the client the changes that have happened. But we do all this in a much tighter cycle that we call a sprint. And that typically a sprint will last for about 2 weeks. Some companies run sprints every week, some run every 4 weeks. It's up to you as a team to decide how long you want to actually run a sprint. But typically it's 2 weeks. And so every 2 weeks, the client is able to provide feedback into that loop. And so you were able to move quickly through iterations. And so if we get to the end of sprint 2 and the client says, hey, you know what, we need to make a change, you can make those changes quickly and effectively for sprint 3. What we have here is a breakdown of the ceremonies and the approach that you bring to Agile. So typically what will happen is that a product leader will build out a backlog of products and what we call a product backlog. And this will be just a whole bunch of different features, and they may be small features or bug fixes, all the way up to large features that may actually span over multiple sprints. But when you go through the sprint planning, you want to actually break out the work that you're doing so the team has a mixture of small, medium, and large solutions that they can actually implement successfully into their sprint plan. And then once you actually start running your sprint, again, it's a 2-week activity. You meet every single day with the actual sprint team to ensure that everybody is staying on track, and if there's any blockers, that those blockers are being addressed effectively and immediately. The goal at the end of the 2 weeks is to have a deliverable product that you can put in front of the customer, and the customer can then do a review. The key advantages you have of running a sprint with Agile is that the client requirements are better understood because the client is really integrated into the Scrum team. They're there all the time. And the product is delivered much faster than with a traditional waterfall model. You're delivering features at the end of each sprint versus waiting weeks, months, or in some cases years for a waterfall project to be completed. However, there are also some distinct disadvantages. The product itself really doesn't get tested in a production environment. It's only being tested on the developer computers. And it's really hard when you're actually running Agile for the sprint team to actually build out a solution easily and effectively on their computers to mimic the production environment. And the developers and the operations team are running in separate silos. So you have your development team running their sprint and actually working to build out the features. But then when they're done at the end of their sprint and they want to do a release, they kind of fling it over the wall at the operations team. And then it's the operations team job to actually install the software and make sure that the environment is running in a stable fashion. That is really difficult to do when you have the two teams really not working together. So here we have is a breakdown of that process with the developers submitting their work to the operations team for deployment. And then the operations team may submit their work to the production servers, but what if there is an error? What if there was a setup configuration error with the developer's test environment that doesn't match the production environment? There may be a dependency that isn't there. There may be a link to an API that doesn't exist in production. And so you have these challenges that the operations team are constantly faced with. And their challenge is that they don't know how the code works. So this is where DevOps really comes in. And let's dig into how DevOps, which is developers and operators working together, is the key for successful continuous delivery. So DevOps is an evolution of the Agile model. The Agile model really is great for gathering requirements and for developing and testing out your solutions. And what we want to be able to do is kind of address that challenge and that gap between the ops team and the dev team. And so with DevOps, what we're doing is bringing together the operations team and the development team into a single team. And they are able to then work more seamlessly together because they are integrated to be able to build out solutions that are being tested in a production-like environment so that when we actually deploy, we know that the code itself will work. The operations team is then able to focus on what they're really good at, which is analyzing the production environment and being able to provide feedback to the developers on what is being successful. So we're able to make adjustments in our code that is based on data. So let's step through the different phases of a DevOps team. So typically you'll see that the DevOps team will actually have 8 phases. Now this is somewhat similar to Agile, and what I'd like to point out at the time is that again, Agile and DevOps are very closely related, that Agile and DevOps are closely related delivery models that you can use. With DevOps, it's really just extending that model with the key phases that we have here. So let's step through each of these key phases. So the first phase is planning, and this is where we actually sit down with a business team and we go through and understand what their goals are. The second stage is, as you can imagine, and this is where it's all very similar to Agile, is that the coders actually start coding. But they'll start using tools such as Git, which is a distributed version control software. It makes it easier for developers to all be working on the same code base rather than bits of the code rather than them working on bits of the code that they are responsible for. So the goal with using tools such as Git is that each developer always has the current and latest version of the code. You then use tools such as Maven and Gradle as a way to consistently build out your environment. And then we also use tools to actually automate our testing. Now, what's interesting is when we use tools like Selenium and JUnit is that we're moving into a world where our testing is scripted, the same as our build environment and the same as using our Git environment. We can start scripting out these environments. And so we actually have scripted production environments that we're moving towards. Jenkins is the integration phase that we use for our tools. And another point here is that the tools that we're listing here, these are all open source tools. These are tools that any team can start using. We want to have tools that control and manage the deployment of code into the production environments. And then finally, tools such as Ansible and Chef will actually operate and manage those production environments so that when code comes to them, that code is compliant with the production environment, so that when the code is then deployed to the many different production servers, that the expected results of those servers, which is you want them to continue running, is received. And then finally, you monitor the entire environment so you can actually zero in on spikes and issues that are relevant to either the code or changing consumer habits on the site. So let's step through some of those tools that we have in the DevOps environment. So here we have is a breakdown of the DevOps tools that we have. And again, one of the things I want to point out is that these tools are open source tools. There are also many other tools. This is just really a selection of some of the more popular tools that are being used. But it's quite likely that you're already using some of these tools today. You may already be using Jenkins. You may already be using Git. But some of the other tools really help you create a fully scriptable environment so that you can actually start scripting out your entire DevOps tool set. This really helps when it comes to speeding up your delivery, because the more you can actually script out the work that you're doing, the more effective you can be at running automation against those scripts, and the more effective you can be at having a consistent experience. So let's step through this DevOps process. So we go through and we have our continuous delivery, which is our plan, code, build, and test environment. So what happens if you want to make a release? Well, the first thing you want to do is send out your files to the build environment, and you want to be able to test the code that you've been created. Because we're scripting everything in our code, from the actual unit testing being done to the all the way through to the production environment, because we're testing all of that, we can very quickly identify whether or not there are any defects within the code. If there are defects, we can send that code right back to the developer with a message saying what the defect is, and the developer can then fix that with information that is real on either the code or the production environment. If, however, your code passes the scripting tests, it can then be deployed. And once it's out to deployment, you can then start monitoring that environment. What this provides you is the opportunity to speed up your delivery. So you go from the waterfall model, which is weeks, months, or even years between releases, to Agile, which is 2 weeks or 4 weeks, depending on your sprint cadence, to where you are today with DevOps, where you can actually be doing multiple releases every single day. So there are some significant advantages, and there are companies out there that are really zeroing in on those advantages. If we take any one of these companies, such as Google, any given day will actually process 50 to 100 new releases on their website through their DevOps teams. In fact, they have some great videos on YouTube that you can find out on how their DevOps teams work. Netflix is also a similar environment. Now, what's interesting with Netflix is that Netflix have really fully embraced DevOps within their development team. And so they have a DevOps team, and Netflix is a completely digital company. So they have software on phones, on smart TVs, on computers, and on websites. Interestingly, though, the DevOps team for Netflix is only 70 people. And when you consider that a third of all internet traffic on any given day is from Netflix, it's really a reflection on how effective DevOps can be when you can actually manage that entire business with just 70 people. So there are some key advantages that DevOps has. It's the actual time to create and deliver software is dramatically reduced, particularly compared to waterfall. Complexity of maintenance is also reduced because you're automating and scripting out your entire environment. You're improving the communication between all your teams. So teams don't feel like they're in separate silos, but that are actually working cohesively together. And that there is continuous integration and continuous delivery so that your consumer, your customer, is constantly being delighted.
If you're into the tech industry or just curious about the role of DevOps in software development, you have come to the right place. So what exactly is DevOps? In simple terms, it's a set of practices and tools that help developers and operational team work better together, releasing software faster with higher quality. At its core, DevOps is about breaking down barriers between development and operations and creating a culture of collaboration that focuses on delivering value to customers as quickly and efficiently as possible. Of course, this is a vast oversimplification, and there are many different aspects to DevOps that we could spend hours diving into. But for now, let's focus on some of the key responsibilities of a DevOps engineer, who is the person responsible for implementing and overseeing DevOps practices and processes.
But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to Simplilearn to stay updated with all the latest technologies, and hit that bell icon to never miss an update from us. Having said that, the demand for DevOps professionals has overgrown in recent years as more and more companies adopt DevOps practices to improve their software development and delivery processes. So are you ready to advance your professional career to the next level? It aims to streamline the entire software development lifecycle by integrating and optimizing processes, tools, and methodologies. It encourages a culture of shared responsibility where developers and operations team work together closely throughout the entire software development lifecycle, from planning and coding to testing, deployment, and monitoring. Now the question is, who is a DevOps engineer? Well, you got it right. A DevOps engineer is a professional who combines software development expertise with operations knowledge to facilitate collaboration, streamline processes, and improve software delivery and infrastructure management within an organization. A DevOps engineer role is to bridge the gap between development and operations team, enabling efficient and reliable software development and deployment practices. But the question is how to become a DevOps engineer. What are the skills that you need to possess to become a good DevOps engineer? Well, a DevOps engineer possesses a wide range of skills, including proficiency in scripting and programming languages, knowledge of various tools and technologies, expertise in system administration, cloud platforms, and containerization technologies, as well as strong problem solving and communication skills are necessary. Firstly, having a good coding knowledge. Well, tools like Confluence, Jira, Git, these tools can support and enhance collaboration and project management within a DevOps environment. Next, having a good knowledge on deployment tools are also necessary. Now, tools like DCOS provides orchestration capabilities for distributed applications, Docker enables containerization for consistent and scalable deployments, and AWS offers a broad range of cloud services for infrastructure provisioning, scalability, and managed services. Next, you need to have a good knowledge on operations tools as well. Now, Chef and Ansible focus on infrastructure automation and configuration management, while Kubernetes specializes in container orchestration and management. These tools are utilized in DevOps to automate various aspects of software development life cycles, including infrastructure provisioning, configuration, management, application deployment, and scaling. Moving ahead, you need to have a strong grip on monitoring tools. Nagios, Splunk, and Datadog are three commonly used tools in the field of monitoring and observability. Now, each tool serves a specific purpose in monitoring and managing system and applications. Nagios specializes in infrastructure and application monitoring. Splunk focuses on log analysis and data visualization. Datadog provides comprehensive monitoring and analytic capabilities in cloud environments. These tools play a crucial role in maintaining the health and performance of systems and applications. Moving ahead, you need to have a good knowledge on Jenkins and CodeShip. Now, Jenkins and CodeShips are both essential tools in DevOps practices. Jenkins is a flexible and extensible automation server that supports continuous integration, testing, and deployment. On the other hand, CodeShip is a cloud-based CI/CD platform that offers simplicity and ease of use, particularly for cloud-native applications. Both these tools contribute to improving development productivity and code quality. And finally, having a good knowledge on testing tools like Selenium, JUnit are necessary for a DevOps engineer. JUnit is primarily focused on unit testing and automated testing of Java code, while Selenium is geared towards functional testing and automation of web applications. Both these tools play critical roles in DevOps workflow, contributing to faster feedback cycles, improved code quality, and reliable software releases. So these are some of the main and important skills that you need to possess as a DevOps engineer. Before moving ahead, let's take a minute and listen to the experiences of our learners who have enrolled in the DevOps PGP program, which has proven to be highly beneficial for many aspiring engineers and professionals, leading them to achieve new heights in the field of DevOps. Well, now comes the main part. What exactly are the day-to-day roles and responsibilities of a DevOps engineer? Now, a DevOps engineer plays a crucial role in bridging the gap between development and operations team, as we discussed earlier. So here are some of the top 5 roles and responsibilities of a DevOps engineer in detail. First on the list, we have collaboration and communication. Now, DevOps engineers facilitate effective communication and collaboration with development and operations team. They actively participate in meetings and discussions to align goals and expectations. Now, as a DevOps engineer, you need to engage in regular meetings and discussions. Regular engagement ensures that they are up to date with ongoing projects, challenges, and goals, enabling them to better align their efforts and contribute effectively. Regular engagement ensures that they are up to date with ongoing projects, challenges, and goals, enabling them to better align their efforts and contribute effectively. Actively listen and understand the requirement, concerns, and feedback. Now, when engaging with development and operations team, DevOps engineers practice active listening. They pay close attention to the requirements, concerns, and feedback expressed by team members from both the sides. By understanding their perspectives, pain points, and suggestions, DevOps engineers can better assess the needs of their teams and collaborate to find suitable solutions. Facilitate effective communication channels. Now, DevOps engineers take the initiative to establish and maintain effective communication within the organization. This often involves setting up dedicated chat platforms like Slack, Microsoft Teams, or collaboration tools like Jira to foster better collaboration and ensure that information flows smoothly between the teams. And finally, encourage cross-functional collaboration. Now, DevOps engineers recognize the value of cross-functional collaboration and knowledge sharing among the team members. They actively encourage them from development and operations team to collaborate, exchange ideas, and share their expertise. Second on the list, we have infrastructure automation and configuration management. Now, DevOps engineers focus on automating infrastructure provisioning and managing configurations using certain tools. They define infrastructure as code, enabling efficient deployment and scaling of resources. Now, as a DevOps engineer, you have to identify the infrastructure requirements effectively. Now, DevOps engineers work closely with development teams to understand the infrastructure requirements of the application. This involves analyzing the needs of applications in terms of computer resources, storage, security, networking, and scalability. By gathering all these requirements, DevOps engineer can ensure that infrastructure is provisioned and configured to meet the application specific need and future growth. Write infrastructure automation scripts and templates. Now, once the infrastructure requirements are identified, DevOps engineers use automation tools and techniques to define the desired state of infrastructure components. They write scripts and templates that specify how the infrastructure should be provisioned, configured, and managed. Automate the provisioning, configuration, and management of servers. Well, DevOps engineers leverage infrastructure as code, or in short IAC principles, to automate the provisioning, configuration, and management of servers, networks, and other infrastructure resources. They use tools like Ansible, Chef, or Puppet to automate the deployment and configuration of infrastructure components. And finally, regularly update infrastructure code. Now, DevOps engineer uses version control systems like Git to track changes, collaborate with team members, and manage different versions of infrastructure code. By regularly updating and versioning infrastructure code, DevOps engineers can easily track and revert changes whenever necessary. Now, third on the list, we have continuous integration and continuous deployment, or CI/CD in short. Now, DevOps engineers are responsible for establishing and maintaining CI/CD pipelines, which enable developers to integrate code changes seamlessly and deploy applications rapidly. So for that, they have to set up a version control system. Now, version control systems like Git play a crucial role in DevOps by providing a centralized repository for managing code and tracking changes. Setting up a version control system involves creating a repository, initializing it with the code, and defining branching and merging strategies. Configure a build server. Now, a build server automates the process of compiling, testing, and packaging application code. Tools like Jenkins and GitLab CI/CD allows you to define build pipelines that specify the steps to be executed. These pipelines typically involve tasks such as pulling code from repository, compiling source code, generating artifacts, and packaging the application. Next, automate the deployment process. Now, automation of the deployment process is crucial for achieving rapid and consistent software releases. Containerization tools like Docker provide a lightweight and portable way to package application and their dependencies. Docker containers can be created and deployed consistently across different environments, ensuring consistency between development, testing, and production. Define and enforce quality gates and monitor CI/CD KPIs. Quality gates ensure that the code meets predefined quality standards before it is promoted to the next stage of the CI/CD pipeline. Automated testing, including unit test, integrated test, and end-to-end test. Integration test and end-to-end test help catch bugs and validate the functionality of the managing applications. And finally, measuring KPIs of the CI/CD pipeline provide insights into its performance and help identify areas for improvement. Well, next we have monitoring and performance optimization. Now, DevOps engineers monitor system performance, identify and optimize the infrastructure and application stacks whenever necessary. They implement monitoring tools to collect and analyze metrics, logs, and traces. So for that, select and configure monitoring tools. Now, monitoring tools like Prometheus or Grafana can be used to collect and visualize these metrics, allowing teams to identify bottlenecks or optimize processes and enhance the overall efficiency of the CI/CD pipeline. Also, they have to collaborate with the development and operations team to fine-tune application performance. So, continuously optimizing the infrastructure, which will ensure high availability, scalability, and reliability of that application. And finally, we have security and compliance. Now, DevOps engineers play a critical role in implementing security measures and ensuring compliance with industry standards and regulations. They work closely with security teams to define and implement security controls throughout the software delivery pipeline. So they have to continuously collaborate with the security teams to identify and define security requirements and controls, and implement security measures such as vulnerability scanning, access management, and secure configuration. They have to continuously integrate security testing and code analysis into the CI/CD pipeline and monitor for any sort of potential security risks or breaches and respond promptly to mitigate any identified vulnerabilities. So these were some of the main or top 5 roles and responsibilities of a DevOps engineer.
Talking about the salary figures of a senior DevOps engineer, according to Glassdoor, a senior DevOps engineer working in the United States earns a whopping salary of $178,362. The same senior DevOps engineer in India earns 18 lakh rupees annually. To sum it up, as you progress from entry level to mid level and eventually to experienced DevOps engineer, your roles and responsibilities evolve significantly. Each level presents unique challenges and opportunities for growth, all contributing to your journey as a successful DevOps professional. So excited about the opportunities DevOps offers? Great. Now let's talk about the skills you will need to become a successful DevOps engineer. Coding and scripting. Strong knowledge of programming languages like Python, Ruby, or JavaScript and scripting skills are essential for automation and tool development. System administration. Familiarity with Linux, Unix, and Windows systems, including configuration and troubleshooting. Cloud computing. Proficiency in cloud platforms like AWS, Azure, or Google Cloud to deploy and manage applications in the cloud. Containerization and orchestration. Understanding container technologies like Docker and container orchestration tools like Kubernetes is a must. Continuous integration or deployment. Experience with CI/CD tools such as Jenkins, GitLab CI, or Circle CI to automate the development workflow. Infrastructure as code. Knowledge of IAC tools like Terraform or Ansible to manage infrastructure programmatically. Monitoring and logging. Familiarity with monitoring tools like Prometheus, Grafana, and logging solutions like ELK Stack. Acquiring these skills will not only make you a valuable DevOps engineer, but will also open doors to exciting job opportunities. So to enroll in the postgraduate program in DevOps today, click the link mentioned in the description box below. Don't miss this fantastic opportunity to invest in your future. So let's take a minute to hear it out from our learners who have experienced massive success in their career through a postgraduate program in DevOps.
DevOps, a combination of development and operations, is a software development approach that emphasizes collaboration, automation, and continuous integration and delivery. DevOps has gained immense popularity in recent years due to its ability to enhance software development processes, streamline operations, and improve overall efficiency. So, if you're interested in learning DevOps from scratch, this video will guide you through a comprehensive roadmap, providing you with a clear path to mastering the principles and practices of DevOps. But before that, if you want to learn about DevOps and its concept in depth, then Simplilearn's Caltech postgraduate program in DevOps will be the right choice for you. This DevOps course is designed in collaboration with Caltech CTME for a professional development option that will square your skills with industry standards. In this course, you will learn how to formalize and document development processes and create a self-documenting system. DevOps certification course will also cover advanced tools like Puppet, SolStack, and Ansible that help self-governance and automated management at scale. So, why wait? Check out the course link mentioned in the description. Now, let's dive into the video. But let's start with understanding the different software development methodologies present out there. Well, software development models, also known as software development methodologies or processes, are systematic approaches used to plan, design, develop, and deliver software applications. There are several different types of software development models, each with its own set of principles, practices, and characteristics. So, first among them is waterfall model. The waterfall model is a sequential software development approach that follows a linear progression through various phases, including requirements gathering, design implementation, testing, deployment, and maintenance. Each phase is completed before moving on to the next, and it relies heavily on upfront planning and documentation. It is often used in projects with well-defined requirements and stable environments. Second is Agile model. Now, Agile methodologies such as Scrum and Kanban emerged as a response to the limitations of the waterfall method. Agile focuses on iterative and incremental development with frequent feedback and collaboration between cross-functional teams. The project is divided into smaller time-boxed iterations and sprints, where features are developed, tested, and delivered in a rapid and flexible manner. Agile methodologies prioritize adaptability, customer satisfaction, and continuous improvement. And third is DevOps. Now, DevOps is not a software development model per se, but rather a cultural and operational philosophy that emphasizes collaboration and integration between software development and IT operations teams. It aims to automate and streamline the entire software delivery pipeline, from development and testing to deployment and monitoring. DevOps encourages closer collaboration, shared responsibilities, and the use of automation tools to achieve faster and more reliable software releases. It promotes a continuous delivery approach, allowing frequent and smaller updates to be deployed. In short, DevOps is a philosophy and set of practices that transcends traditional software development models. It emphasizes collaboration, automation, continuous delivery, and a holistic view of software development and operations. By combining development and operations into a unified approach, DevOps strives to achieve faster, more reliable, and customer-centric software delivery. Now that we have understood why DevOps is different from other software development models and why is it so important to learn, now let's see how you can learn DevOps from scratch. So the first step is understand the core concepts. Well, to embark on your DevOps journey, it is crucial to grasp the core concepts. DevOps involves cultural process and technical aspects. Start by understanding the key principles such as continuous integration, continuous delivery, infrastructure as code, and automation. Continuous integration involves integrating code changes frequently into a shared repository and running automated tests to catch issues early. Continuous delivery focuses on automating the deployment process, ensuring that software is always in a releasable state. Infrastructure as code emphasizes managing infrastructure resources through code, enabling scalability, consistency, and reproducibility. Automation plays a pivotal role in reducing manual effort and increasing efficiency throughout the software development cycle. Second is learn version control system. Well, version control system is a fundamental aspect of DevOps. Git, a widely used version control system, allows you to track changes in your code base, collaborate with team members, and manage different versions of your code. So, begin by learning the basic of Git commands, such as initializing a repository, creating branches, committing changes, and merging branches. Gain hands-on experience by creating repositories, collaborating with others using Git, and understanding branching strategies that facilitate parallel development and merging code changes. Third is master configuration management. Now, configuration management is essential for efficient management and deployment of software configurations across various environments. Explore popular configuration management tools like Ansible, Chef, or Puppet. These tools enable you to define the desired state of your infrastructure and automate configuration management tasks. Learn how to write infrastructure code, known as playbooks or recipes, which specify the desired configuration of servers and services. Automating configuration management ensures consistency, reduces manual errors, and simplifies infrastructure management at scale. Then dive into continuous integration and continuous delivery. Now, continuous integration and continuous delivery are integral to DevOps practices, enabling teams to deliver software rapidly and reliably. CI involves regularly integrating code changes into a shared repository and running automated tests to identify issues early. Explore popular CI/CD tools like Jenkins, Travis CI, or GitLab CI/CD. Set up CI/CD pipelines which automate the build, test, and deployment processes. Learn how to configure these pipelines to compile and test code, run unit tests, execute integration tests, and deploy applications to various environments. Gain hands-on experience in automating the release process and delivering software frequently with confidence. Next is embrace infrastructure as code. Infrastructure as code is a vital component of modern DevOps practices. It involves managing infrastructure resources through code, enabling you to provision and configure infrastructure programmatically. Learn tools like Terraform or AWS CloudFormation to define infrastructure resources such as servers, networking, and storage. Understand the declarative nature of infrastructure code and how it allows for reproducibility and scalability. Gain knowledge of cloud platforms like AWS, Azure, or Google Cloud, and explore their respective DevOps tooling to automate infrastructure provisioning, scaling, and monitoring. Next, explore containerization and orchestration. Now, containerization technologies like Docker have revolutionized software development by providing lightweight, isolated environments for applications. Begin by understanding containers, their benefits, and how they differ from traditional virtual machines. Learn how to create and manage Docker containers, package your applications into containers, and ensure consistency across different environments. Dive into container orchestration platforms like Kubernetes, which allows you to automate the deployment, scaling, and management of containers. Understand concepts like pods, deployments, services, and ingress, and gain practical experience by deploying applications using containerization and orchestration tools. Next, adopt monitoring and logging. Monitoring and logging play a crucial role in ensuring application stability and performance. Learn about monitoring tools like Prometheus, Grafana, or Nagios, which enables you to collect and visualize metrics and gain insights into the health of your systems. Explore logging frameworks like the ELK stack, like Elasticsearch, Logstash, Kibana, which provide a centralized platform for collecting, analyzing, and visualizing logs. Understand how to set up monitoring and logging systems, configure alerting and troubleshoot issues in real time, and gain insights into the performance, availability, and reliability of your applications. Next, emphasize security and compliance. Security is an essential aspect of DevOps practices. Incorporate security principles and best practices into your DevOps workflow. Learn about secure coding practices, vulnerability scanning tools, and penetration testing methodologies. Understand compliance standards and frameworks like PCI DSS, HIPAA, and GDPR, and ensure that your systems adhere to these regulations. Explore security-focused tools and techniques to protect your infrastructure, applications, and data. Implement secure authentication, authorization, and encryption mechanisms to ensure the integrity and confidentiality of your systems. Next is continuous learning and improvement. Well, DevOps is a continuously evolving field with new tools and technologies emerging regularly. Stay updated with the latest industry trends by following blogs, forums, and conferences. Engage with the DevOps community, participate in discussions, and contribute to open source projects. Continuous learning and improvement are key to mastering DevOps. Take up projects, experiment with different tools and techniques, and continually refine your skills. Participate in hackathons, attend workshops, and pursue relevant certifications to enhance your knowledge and stay competitive.
Now, in a world driven by rapid technological advancements, businesses are constantly seeking ways to deliver software faster and more efficiently. Enter DevOps, the dynamic philosophy that has revolutionized the software development and operations landscape. DevOps is not just a buzzword, it's a game-changing approach that bridges the gap between developers and operations team, fostering collaboration and enhancing the entire software development lifecycle. Now, at its core, DevOps embodies a cultural shift towards seamless integration and continuous delivery. It promotes a collaborative environment where developers, system administrators, quality assurance professionals, and other stakeholders work together harmoniously and promoting cross-functional communication. DevOps empowers teams to streamline processes, automate workflows, and ultimately deliver high-quality software at an accelerated pace. Having said that, the demand for DevOps professionals has overgrown in recent years as more and more companies adopt DevOps practices to improve their software development and delivery processes. So, are you ready to advance your professional career to the next level? Taking our step-by-step Simplilearn's postgraduate program in DevOps in collaboration with IBM will help you start your DevOps journey that will prepare you for the DevOps engineer role. So in order to match your skills with market demand, this DevOps training program is designed in collaboration with Caltech CTME. And our cutting-edge blended learning combines live online DevOps certification classes with interactive labs to give you a practical experience. This DevOps training program will cover skills like DevOps methodology, continuous integration, DevOps on cloud infrastructure, deployment automation, and many more. And along with that, you'll also get hands-on experience with the latest tools and techniques including Terraform, Maven, Ansible, Docker, Jenkins, and much more. So if you're looking to pursue your career as a DevOps engineer and acquire these skills that will prepare you for your job, consider enrolling in this intensive training program today. We will leave the link in the description box below, so make sure you check that out. So let us move ahead and proceed with our topic today. So the main question is, what fuels this DevOps revolution? Now, it's a powerful collection of tools specifically designed to support and amplify its principles. So these tools act as a catalyst, empowering teams to automate tasks, manage infrastructure efficiently, and monitor application performance effectively. So without any further delay, let us directly jump into the top 9 noteworthy tools, highlighting their features, benefits, and significance that have become synonymous with the DevOps ecosystem in no particular order. So first on the list, we have Jenkins. Now, Jenkins is an open source automation server known for its extensive plugin ecosystem, making it highly versatile and customizable. It facilitates continuous integration and continuous delivery, or in short, CI/CD pipelines, automating the build, test, and deployment processes. Jenkins enables teams to integrate code frequently, ensuring early detection of issues and faster software releases. So let us now look at some of the key features of Jenkins. Firstly, easy installation and configuration. Jenkins has a user-friendly web interface that simplifies installation, configuration, and management of build jobs and pipelines. Distributed builds for scalability. Now, it supports for a vast ecosystem of plugins for seamless integration, and it can distribute build tasks across multiple nodes, which helps in parallelizing builds and reducing overall build time, especially in large projects. And finally, extensible through scripting languages like Groovy. Now, Jenkins provides extensibility through scripting languages like Groovy, which is a powerful and versatile language that runs on the Java virtual machines, or in short JVM. So by leveraging Groovy's scripting capabilities, Jenkins becomes highly adaptable and customizable to meet the specific requirements of different development teams and projects. So those are some of the key features of Jenkins. Let us now move ahead and discuss some of the benefits or advantages of using Jenkins. So firstly, we have enables faster feedback and quicker time to market. Now, Jenkins' continuous integration capabilities enable developers to merge their code changes into a shared repository regularly. By doing so, Jenkins automatically triggers build and testing processes to validate any kind of changes. This automates feedback loop, allows developers to receive quick feedback on the quality of their code. So as a result, issues and bugs can be identified early in the development cycle, preventing the accumulation of defects and reducing the time required to fix them. As discussed earlier, it also facilitates early issue detection and reduced bug turnaround time. Now, with Jenkins running automated builds and tests every time new code is committed, potential issues and bugs are caught early in the development process. So by detecting issues at an early stage, developers can address them promptly before they propagate further into the code base. And finally, automates repetitive tasks, same time and effort. Now, Jenkins automates various tasks involved in the software development lifecycle. This includes tasks such as building the code, running tests, and deploying applications. By automating these repetitive and time-consuming tasks, Jenkins saves developers and operations teams significant amount of time and efforts. So that is what Jenkins is all about. It's so widely adopted in the DevOps landscape due to its flexibility and extensive plugin support. And learning it will add a great value to your array of skills. So its ability to automate CI/CD processes and integrate with various tools makes it a crucial component of modern software development and delivery pipelines. Second on the list, we have Docker. Docker has revolutionized application deployment with its containerization approach. It allows developers to package applications and their dependencies into lightweight, isolated containers. Docker containers provide consistency across different environments, ensuring that applications run consistently regardless of the underlying infrastructure. This portability, along with the rapid startup times and efficient resource utilization, has made Docker a foundational tool in DevOps practices. So let us now discuss some of the key features of Docker. First one is packaging applications and dependencies into containers. Now, Docker allows developers to package their applications and all their dependencies into a self-contained unit called containers, and the process is known as containerization. Now, these containers encapsulate the application code, its runtime, various libraries, and system tools required to run the application. By doing so, Docker ensures consistency across different environments. Secondly, efficient resource utilization through containerization. Now, this lightweight nature of containers allows for more efficient resource utilization. Multiple containers can run on a single physical machine without the need for individual OS instances. It means that you can host more applications and services on the same hardware, reducing the number of servers needed. And finally, easy scaling and management of containers. Now, containerization simplifies application scaling and management. So when you need to handle increased application load, you can quickly scale by running more instances on the containerized application, on additional servers, or within a container orchestration platform like Kubernetes. So let us now talk about some of the benefits of the Docker tool. Now, firstly, rapid deployment and scalability. Docker enables rapid deployment of applications due to its lightweight and containerized approach. When using Dockers, developers package their applications and dependencies into containers which encapsulate everything needed to run the application. So these containers are portable and can be easily moved from one environment to the other. And next, we have the isolation of applications and dependencies for improved security. Docker utilizes containerization to isolate applications and the dependencies from the ecosystem and other containers. Each containers operate in its own user space, separate from other containers, providing a strong level of isolation. This isolation prevents applications from affecting each other and helps contain potential security breaches within the confines of the container. And finally, simplify development to production workflow. Now, Docker streamlines the development to production workflow by providing consistency between different environments. With Docker, developers can create containers that run the same way in development, testing, and production environments, thereby reducing the chances of unexpected issues arising during the deployment. So Docker has become a cornerstone of modern DevOps practices. Its ability to streamline application deployment and improve resource utilization has transformed software development and operations, enabling faster and more reliable application delivery. So that was all about Docker. So let us now move ahead and discuss the next tool, which is Kubernetes. So next on the list, we have Kubernetes. Kubernetes is an open source container orchestration platform that automates the deployment, scaling, and management of containerized applications. It provides a robust infrastructure for running and coordinating containers across clusters of machines, making it easier to manage large-scale deployments. DevOps teams can easily deploy, update, and scale applications, facilitating faster and more reliable software delivery while promoting collaboration and consistency across development and operations lifecycle through Kubernetes. So let us look at some of the key features of it. Automatic container deployment and scaling. Now, container orchestration platforms like Kubernetes provide automatic container deployment and scaling capabilities. When deploying applications on Kubernetes, you can define the desired state of your application using YAML files on declarative configuration. Kubernetes then takes care of this, ensuring that specified number of container replicas is running at all times. Service discovery and load balancing. Now, Kubernetes enables faster feedback and quicker time to market. In a containerized environment, multiple instances of an application may be running across different containers, making it challenging for clients or other services to know the IP addresses of all the running instances and detecting and keeping tracking of the locations of various services within the container cluster. And Kubernetes, for example, provides a built-in service discovery mechanism. Next, we have self-healing and auto-restart of containers. Now, container orchestration platform provides self-healing capabilities to ensure that applications are always available and responsive. If a container fails due to an application crash or any other issues, the orchestration platform detects the failure and automatically restarts the failed container. So let us now move ahead and discuss some of the benefits of using Kubernetes tool. Firstly, it is scalable and highly available application, and it provides a seamless scaling of resources based on demand. Next, it has a simplified management of containerization applications across various clusters. And finally, automated deployment and updates, reducing manual intervention, which further improves resource utilization and optimization. Overall, Kubernetes has emerged as the industry standard for container orchestration. Its ability to automate application deployment, scaling, and management simplifies the complexities of running containerized applications at scale, making it a crucial tool for DevOps practitioners. Moving ahead, let us discuss our next tool, which is Ansible. Ansible is a powerful automation tool that simplifies configuration management, application deployment, and orchestration. It employs a declarative language to define desired state configuration, making it easy to manage and automate infrastructure tasks. Ansible follows an agentless architecture, allowing it to work efficiently across a wide range of systems and environments. So let us now look at some of its features. Firstly, it's a declarative language for defining infrastructure configuration. And it is also an agentless architecture for easy deployment and management, as we discussed earlier. Now, this is done through a playbook-driven automation for orchestration, where extensive library of modules for a wide range of tasks are employed. So let us now discuss some of its benefits. So firstly, it's simplified infrastructure management through automation, which increases the operational efficiency with reduced manual tasks. And its idempotent nature ensures that it has consistency and predictability overall. And finally, it supports a wide range of infrastructure automation use cases, and with its agentless architecture, it allows easy integration with various systems and environments. So, in a nutshell, Ansible's simplicity, flexibility, and ease of use have made it a popular choice for automating infrastructure and application deployment tasks. Active approach and agentless architecture contribute to efficient and streamlined development workforce. So moving ahead, the next tool on our list is Git. It is a distributed version control system that has become a fundamental tool for modern software development practices. It allows developers to track changes, collaborate effectively, and manage code base efficiently. Git's decentralized architecture ensures that developers can work offline and merge changes seamlessly across branches. Let us now discuss some of its key features. Now, its distributed version control system has efficient collaboration with various tools within the management of the ecosystem of DevOps, and it also has an integration with various code hosting platforms, which is the branching and merging capabilities for concurrent development. And finally, its support for code reviews and collaboration workflows, which also gives a commit-based tracking of changes. So these are some of the key features of Git. So let us now discuss some of the advantages or benefits of using Git. So firstly, it's easy tracking and management of code changes, which ensures efficient collaboration and concurrent development within the resource files. And its ability to work offline and merge changes seamlessly will benefit a lot of DevOps engineers. And finally, its easy integration with other DevOps tools makes it a wonderful to use to manage code versions, track changes, and enable efficient collaboration, which has revolutionized the software development. So it has become an essential tool for version control, facilitating effective collaboration and enabling streamlined DevOps workflows. So moving ahead, the next tool on our list is Terraform. Now, Terraform is an infrastructure as code, or in short IAC tool, that allows teams to define and provision infrastructure resources in a declarative manner. It supports multiple cloud providers and enables consistent and reproducible infrastructure deployment. Terraform's declarative syntax and state management capabilities simplify infrastructure provisioning and configuration. Let us now look at some of its key features. Firstly, it provides multi-cloud support for provisioning resources across different providers. Its infrastructure as code approach for consistent and reproducible deployments makes it a declarative syntax for defining infrastructure configurations. And finally, automated resource provisioning and dependency management. So some of its benefits or the advantages of using Terraform is its simplified resource provisioning and dependency management. Now, Terraform's infrastructure as code approach supports for multiple cloud providers makes it an essential tool for managing infrastructure codes and collaboration and version control for infrastructure configurations as well. And finally, it's state management for tracking infrastructure changes, which makes it a beneficial tool for DevOps engineers. Now, Nagios is used to monitor and manage the health and performance of the infrastructure, application, and network resources. It's a comprehensive monitoring solution to identify and resolve issues proactively, ensuring high availability and reliability of systems. So let us look some of its key features. Firstly, its monitoring capabilities. Secondly, its centralized configure management. And finally, its event handling and escalation tool. So learning Nagios is also crucial and beneficial if you are just starting on DevOps journey. So moving ahead, let us now discuss our next tool on our list, which is ELK Stack. Now, ELK Stack offers a comprehensive solution for centralizing logs from various applications and systems, making it easier for DevOps teams to monitor, troubleshoot, and gain valuable insights from their log data. The ELK Stack, comprising Elasticsearch, Logstash, and Kibana, provides a comprehensive log management and analysis platform. It acts as a distribution search and analytics engine, while Logstash collects, processes, and transforms logs. And finally, Kibana offers a user-friendly interface for visualizing and exploring data. So some of its key features, including real-time monitoring and alerting, scalable and efficient log storage and retrieval, and distributed search and analytics to data visualization and exploration with Kibana. Let us look at some of its benefits. So firstly, it's real-time monitoring for proactive It's real-time log monitoring for proactive issue detection with the help of centralized log management and analysis. Advanced log analytics for troubleshooting and performance optimization, making it a scalable architecture for handling large-scale volumes of data. And finally, efficient log storage and retrieval for compliance and auditing purposes. In a nutshell, ELK Stack has gained immense popularity for its ability to handle log management and analysis at scale. It empowers DevOps teams with real-time insights into application and infrastructure logs, facilitating effective troubleshooting and performance optimization. Well, finally on the list, we have Jira software. Jira is a widely used project management tool that supports agile development methodologies. It offers robust features for planning, tracking, and managing tasks, issues, and workflows. Jira's customizable boards, backlogs, and workflows empower teams to collaborate effectively, visualize, and progress to gain transparency into project statuses. With integration to various DevOps tools, Jira facilitates seamless tracking of development activities, enabling continuous improvement and efficient project management. Some of its key features are customizable boards, workflows for project management, agile planning and estimation features, issue tracking and management capabilities. And some of its benefits include efficient task management and tracking, enhanced collaboration and visibility across various teams, and integration with various DevOps tools for streamlined workflows. It also helps in reporting and analytics for project insights and performance measurement. Finally, Jira has become a go-to tool for agile project management in the DevOps ecosystem. Its ability to support agile methodologies, track tasks, and integrate with other DevOps tools makes it a valuable asset for teams seeking efficient project management and continuous improvement. So learning it will add a great value to your area of skills again. So these were some of the top 9 DevOps rules that you must know, which will help you enhance and accelerate your career in DevOps.
Scenario before using Git, one of the challenges that a lot of developers and development teams would have had is developers would be working on different types of code, whether it was database code, whether it was Python, or whether it was Java or .NET, and they would have a central server that they would be pushing all of their source code in. But there was little or no communication that was actually going on in between all the developers. The challenge you had with that scenario is that when people would be checking in code, you could be like, there'd be conflicts and you'd have to roll back different code versions. And this is really kind of the challenge that Git addresses. Git is a tool that allows all of the developers, no matter what stack they're working in, to have access to all of the code. And it makes it much more effective at being able to have development teams work on small, medium, or even massive applications. And some of the biggest applications out there are managed through a Git distributed server environment. So let's jump into what we'll be covering so you have a clear understanding of the value that you're going to get out of watching this presentation. So we're going to go through DevOps and the tools we have available for DevOps. We'll talk about what version control means within a DevOps environment and cover the 2 different types of version control, centralized and distributed. And then we're going to zero in on Git, which is a really fantastic distributed version control system. And we're going to go through and understand the features, workflow, branches, and commands in Git. We're going to give you a demo and then summarize all of the activities at the end of the presentation. So, what is DevOps? Well, this is one of my favorite questions. I love the idea of what DevOps is. So DevOps really is a culture of being able to deliver solutions faster, where your development teams and your operation teams work effectively together. The idea is to be able to continuously build out solutions and have testing codes that's built into your solutions, so that no matter where they are in the stage of the integration and deployment lifecycle, they're always being tested and you can always have code getting ready to be released out. The idea is that instead of having big releases that you would have maybe once every 2 weeks or once a month, that you would actually have a continuous stream of releases, because you always have code that is being tested, you have your network that's being tested, you have your environment being tested, and you'll be able to provide feedback directly to the appropriate person, whether they're in devs or whether they're in ops, to be able to be successful at being able to deliver solutions faster. The bottom line, your dev team thinks like operations, and your operations team begin to think like developers. It's really a fantastic way of being able to speed up delivery and have your team just think and feel and act in a different cultural environment. So let's have a look at some of the tools that are available to you in a DevOps environment. If we look at DevOps, it's really kind of split into 2 areas. The dev side, you have building, code, planning, and testing. And then on your ops side, you have release, deployment, operating, and monitoring. But the tools really all interact with each other. And what's really great is that the tools are either open source or very, very low in cost. And in fact, most of the tools that you're seeing in front of you right now are open source tools, which means there's no licensing to you, and you can actually effectively manage them and implement them within your team right now. So let's have a look at some of the dev tools that you have for doing code versioning. And so some of the tools that you may have used in the past include Subversion, Team Foundation Service, and Git. These are all different types of version control software that you have out there. One of the oldest ones is Subversion. It's a centralized version control system. It's one of the tools I used years ago. It really is good at doing what it's supposed to do, which is just a very simple version controlled solution. It's open source, so it's free. There's no licensing. There are challenges with working with it because it is a centralized tool rather than a distributed tool, and we'll get into that in a little bit. But for a very basic version control system, it does what you want it to do. Team Foundation Service Solutions is something that many of you in Microsoft world may have been using for a long time. And the thing that's great about TFS is that it's built right into the Microsoft environment. It's the server side, the services side of building out your solutions with Microsoft. Just recently, in the last couple of weeks, at the beginning of September 2018, Microsoft actually just rebranded TFS as Azure DevOps, and so you have Azure Pipelines, and there are 5 now Azure tools that actually replace TFS. But these are all tools that are very similar in concept. The old TFS tools are very similar to the centralized SVN tools, whereas the new tools that are part of Azure are actually much more aligned with Git. So what you're seeing is Microsoft moving from the centralized server to a distributed server with their new Azure DevOps tools, which is fantastic news for every developer listening to this. And then we have Git, and Git is a distributed version control system. It is, again, open source, which means that you can start using it right now without fear of having to have any costs or any penalties. And the thing that's really good about it is that you can use it for almost any kind of digital project. And what it's good at is being able to create that historical record and versioning of your source code, whether you're doing a web application, a mobile application, or you're actually building a Python script for a machine learning solution. So let's dig into what version control systems are and how they can be of value to you. So the role of a version control system is to allow developers to be able to check in their files into a repository. And here you can actually see how we can check in 3 files into a repository, and that repository then becomes a snapshot or a historical record of the files that we're working on. And you want to be able to have it so that the repository is flexible enough so that as you want to be able to scale and add in new files or new versions of a file, that you can actually do that easily within your VCS environment. And the goal is to be able to constantly have each of these versions available so that anybody that wants to be able to check out the file can actually have the latest version or see a history of how that file became what it is today. Let's look at centralized version control systems, and then we'll compare it against distributed version control systems. So a centralized version control system has a central server where all the files are stored, and everybody has to check in and check out from that centralized server, and all of the versions are managed within that server environment. The problem is that if that central server crashes, which doesn't happen but very often, but it can happen, you end up losing all of your files. And I was actually on a project where that actually happened to us, and we lost 6 months of history of how the application was created. Fortunately for us, we actually had a backup, but it didn't have all the historical data. So we were able to at least continue working, but we just lost a lot of files and it took a while to get back into place. So let's now look at and compare this to a distributed version control system. With a distributed version control system, you still have a centralized server that manages the files. But the difference is that as a developer, you check out all of the files for a project. So you can actually manage the whole project locally on your development machine and make your changes. And then you can just check in and out the changes that you've made to the centralized server. The opportunity you have here is that the server itself, if it goes down, you're not going to be in a situation where you lose all of the history, because everybody that's working on the actual application has all of the versions of the code locally on their machine. Now, one of the more popular distributed version control systems that out there is Git. I mean, it really is probably the most popular by a margin compared to a system out there. So, let's dig into, what actually is Git. So Git is a version control system for managing files, and as a developer, you have a Git client on your machine, and you're able to make changes and create local repositories of a program on your computer, and then you can sync up with a remote service such as GitHub or GitLab or the new Azure Labs environment, where you can actually store files remotely and then allow remote teams to have access to those changes in the actual application you made. So you can track your changes easily. The tool is inherently distributed, so it makes it very easy to manage the code for large teams. And you can bring people in very quickly, and you can have people come in as specialists and spin them up quickly and have them work on a piece of the code and then drop them out of the project. If you want to have a check on how this works, go and start contributing to any of the many thousands of open source projects like GitHub, where you can go in with your Git tools and just contribute to those projects. And then finally, one of the things that I really like with Git is that it's not a linear development approach. It's not starting from A and going to Z. It's a non-linear approach, which allows you to have branches that people are working on in parallel to your master branch, where people are actually doing the delivery of the production code. So let's step through some of these features. So Git, as you can imagine, the first thing it does is track history. That's probably the most important part of having a version control system. It's free, open source. You can actually go and use it right now. There are no costs for actually using it. It is a non-linear environment that allows people to be able to build out new features in parallel to the master branch, so that you can be constantly having the master code out there without and adding in new features without breaking the code. And you can automatically create backups because each developer has a version of the code remotely. It's incredibly scalable. Some of the biggest projects out there now are being managed through Git. And because of this scale, the collaboration becomes a byproduct of teams working together. And branching just is so much easier within Git. So as you can see, this whole thing leads to a very effective distributed environment. So let's step through some of the workflow that we have available for Git. So the way that Git works is that you, as an operator, as a developer, you have the Git client on your local development machine, whether it's a Linux machine, a Mac, or a PC, and you connect to a remote server and you pull down the latest working copy, and then you're able to make all of your changes locally, and you can modify the codes, you can review changes, and you can commit those codes to your Git repository that you have locally, and then you can push those changes back up to the remote server. And as soon as you push them into the remote server, those changes then become available to everybody else working on the project. So they can be constantly keeping everybody updated on all the work that is happening. So, typically the way that it would work is, you would start off with having the working file, the working directory that you have locally, and then you would stage those files into a staging area, and then you get those files ready to be committed to your Git repository. And these are all actions that you would do locally and then connect to a remote server. And then later, when you go back into work on your project, the first thing you should always do is check out that code so that you always have the latest version of the code and everybody's kept in sync. So let's talk about branching in Git. So the way that branches work is that if you imagine you're working on a project, and projects always have a tendency of getting bigger than you imagine. And what you want to be able to do is keep that main product working and keeping it working effectively. But if you want to be able to add a feature to that product, you may have 2 or 3 different groups that are working on multiple features simultaneously. And what you want to be able to do is give them the freedom to work on those individual features. And the way you do it in Git is that you can create branches off the master, and while you're off the main branch, which is called the master. And so each person can be working on their own separate branch, and then when they want to, they can then later merge those branches back into the main master. And all this time, the main master still works and still able to produce the right code for the customer. But at the same time, it allows the developers the freedom to be able to write in their new features. And so we can look at this in a little bit more visually with the master branch. And we can put in small features and large features, and we can then merge them back as we need to. So this kind of covers some of the commands that we have in Git. So the first command you'd want to use is called git init, and that's allowing you to go into a folder on your local PC or your local Mac and convert that folder into a local Git repository, and that creates that repository. Then you want to be able to make changes to that repository, and the commands you'd be using in this instance would be add, commit, or status. You want to be able to sync your repositories with the remote server. So be able to put the code that you have on your computer on the remote server, you use push. You want to get the code from the remote server, you'd use pull, and then add origin. And then if you want to do parallel development from the master branch, the main branch, you would use branch, merge, or rebase as ways to be able to do parallel development. And now we're going to go through and do a demo on Git. So we're going to do a demo on Git so you can feel comfortable running the commands in the interface and you're able to get Git running correctly in your environment. So the first thing we're going to do is we're going to set up which version of Git that you have, and then we're going to see if we can establish some global configurations within your Git environment. And we're going to do sandeep.dash as the name, the email address is sandeep.simplylearn, and then we're going to do a list of the different configuration settings we have. So to check the version of Git that we have, we do git -- version in our terminal or command line window. You can also use PowerShell. That'll actually get you running in the same environment as well. All of these tools are going to be command line tools. And then the next thing we're going to do is we're going to assign some global usernames and a global email address so that we can actually access the Git account itself locally on the device. And so we're going to put in config -- global user.name Sandeep, and then git config -- global user.email and sandeep.d@simplylearn.net. And now we're going to check the list of usernames and email IDs in our configuration environment with -list, and you'll see that we have everything in there correctly. Here is our username right here, and our name and our email ID. So if you need any help when you're actually doing any of your work in Git, all you have to do is do git help config or git config -- help, and this will allow you to actually get access to the help screens. So let's just go and type that in, git help config, return, and this takes us to the help page that's running locally on your device. And here we have a breakdown of all the different commands and what those commands actually do within a Git configuration. And we can go ahead and we can do git config -- help, and that will actually take us to the same page. So two ways of doing the same thing. So we're going to go ahead and we're going to create a test repository on our local system, and we're going to do that with make directory called test, and then we're going to move our cursor within command window, terminal window, to the test folder, and then we're going to initialize that folder to become a Git repository. So let's go ahead and do that. So we're going to make a new directory and we're going to call it test, and we're going to move the cursor so it's actually in the test folder. We do cd change directory to test, and you can see now we're actually in the test folder. And now what we have to do is initialize this folder as a Git repository. And so we're going to do this as git init, and it's now a new Git instance that we can actually now use for managing our Git environment. So we're going to create a new file and we're going to call it info.txt, and we're going to put some content in it, and we're actually going to put it in the folder that we've just created so you can actually see what it's like to test out the Git environment with a file that hasn't been checked into it yet. So let's go ahead and do that. So we open up our folder directory, and here you can see we have the test folder, and we're just going to go ahead and create a default test file. So right click, text, new document, info.txt, open that, and you can put really whatever you want in here. We're just going to put in this information right now. Name equals Sam, registration number 12479, and save that file, close it out. Now if we actually go ahead and run a git status command, you'll see that the info.txt file is in red. That's because that file has not actually been checked into the project. It's a new file that we've added, but it hasn't been committed yet into the Git repository. So let's go ahead and see what it takes to actually add the file to the Git repository that we just created. So we're going to do that by doing git add info.txt, and then we're going to commit that into the history of that Git repository. So it now has version control, and we can start doing forking and other kind of similar activities when we connect later to our GitHub Git environment. So we do git add info.txt, and remember we're actually still in the test folder, so it's going to look for that file in that folder and just add it in. And now if we go ahead and do git status, we'll actually be able to see that the info.txt file is in an active color. First of all, we have to commit it, so we go git commit -m, and then we're going to commit, and we add in some quick text here. You can write whatever you want. Committing the text file is now actually committed into the Git repository, and it's still running locally on your PC. So we're going to go make some changes to the file, and we're going to save it, and we want to be able to see how we can use Git to compare the differences between the two files. So let's go over and we're going to make some changes to the info.txt file. Here we are, here's info.txt. We're just going to add in a new line. We're going to add in the line address, and we're going to save that file. And now when we go over to Git, we're going to be able to review the difference. So we're going to do git diff, And here you actually see that we've added in a new address file. So now you can actually see this is the difference between the two documents. Now, as you can imagine, when you have code, this would become more elaborate, where actually will show you code that's been pulled out if you've eliminated any code, or if you added in new code. Really useful. So we're going to go ahead and add our Git username to a remote location so we can actually start testing out the file that we've created into a remote repository. In this case, we're going to use GitHub, and you'll be able to see how we can actually then save that file into a Git repository that somebody else could then access and be able to make edits to. So let's just go ahead and make those changes. So git config-global user.username, and we're going to do Simplilearn. And that will associate it with this Git repository that we've just created locally. So Simplilearn-GitHub. So Simplilearn GitHub is the username that we use on GitHub. So we're going to go over to GitHub. Here we are in GitHub, and then create new repository. And then, as you can see, we're in Simplilearn-GitHub, and we're going to call the new repository test. We're going to make it public so anybody can access it. And you'll see that it automatically adds a README file. And we have our test environment set up correctly. So we'll go ahead and copy the URL link, which is github.com/simplilearn-github/test.git. Copy that, and we'll go back over to our command line window. And so now we're going to add the username to the GitHub configuration. So what we're doing is we're connecting the local repository to the remote repository. So we type git remote add origin, and then we'll paste in the address. And this then allows us to connect the local repository that we created in the test folder with the remote repository. And now we're connected. So now that we've connected, we can actually push the file that we have in the local repository on your PC or Mac to the remote repository in the GitHub server environment. So let's go ahead and do that. So we're going to do git push, and push is the command to push the documents from the origin, which is the local file, to master, and master is a remote file. Hey, and there we are. Success. So what we have now is the file that we just created in our local Git repository is actually now in the remote repository as well, so anybody can access it. So let's go have a look at that. So we're going to refresh the GitHub page, and hey, there we are. There's info.txt has been uploaded, and we're ready to go. That's great. That's what you should be seeing. So refreshing your web page on the remote GitHub folder, and it could be any Git service, but just happen to be using GitHub because it's free to use. You'll be able to see that the local file has been installed and is now part of the Git repository in the remote server. So what we're going to do now is we're going to create 3 more files, and we're just going to call them info.txt, info2, and info3, and then we're going to push them out to the remote server, and we're going to merge everything together into a single environment. So let's go ahead and create those 3 files, and we're just going to add those into the folder. So let's go ahead, create new text document, info1, and then we're going to create info2, and then info3. I'll get my typing right here. Okay, here we go. There we are. Okay, I'm opening info3, and I'm just going to enter some text in here. And what we're going to do is illustrate how we can do branching. And each of these files I'm going to save and then close out. And now I can go over and... So let's create a new branch, and we're going to call this one first_branch. And we go git branch first_branch, and this will be a new branch of the code environment that we're creating. And so hit return, and that allows us to create a new branch. And so what we do is we're going to move to the new branch. So we're going to do git checkout first_branch, and that allows us to move into that branch. And you'll see that info.txt is already there, which is good. That's what we want to see. Now what we need to do is add in the new documents. So here we have the different steps we've taken. We created a branch, we moved to the new branch, and now we're going to go ahead and add the info3 txt to that branch so you can actually see everything coming together. And we're going to go at git add info3.txt. So we're just adding a file like we were previously with our our first initial Git folder, and that file has now been added to the first branch. So we're going to go ahead and commit the file to the first branch, and then we're going to merge the documents into the master branch so we have everything together. So let's go ahead and do those steps. We're going to do the commit first, and then we're going to merge everything together. All right, so we do git commit -m, and we'll just put in, we're just going to say made changes to first branch, and that's just documentation so that we know what we've done. And there we are, we've committed the file. So we had that file info3 txt committed, and now we're going to go ahead and merge the files into the main master, and so we can actually have everything together as one consistent environment. And we do that by typing in, so this lists out what we have in our master file. So we just do ls, and that shows everything in the folder, and we have info.txt, info1 txt, info2 txt, and info3 txt are now all in the first branch. So let's go ahead and we're going to merge. Okay, so actually before we merge, we have to check out the master branch. So we do git checkout master. So it gets us into the master branch, and you'll see that we have just one file in there, info.txt. So we're going to list out the files in the master branch. And so what you'll see is info.text, info1 text, and info2 text are there. But info3 text isn't there because that was created in a separate branch. So let's go ahead and merge the first branch into the master branch. So we do git merge, and we do first underscore branch, and there we are, we've merged it in, and excellent, that looks good. So let's go ahead and list out the files that we have in the master branch, and we do ls, and then you'll see that we have 4 files, including the info3.txt that we had in a separate branch, now all in the master branch. So what are we going to cover today? So we're going to introduce the concept of version control that you will use within your DevOps environment. Then we'll talk about the different tools that are available in a distributed version control system. We'll highlight a product called Git, which is typically used for version control today. And you'll also go through what are the differences between Git and GitHub. You may have used GitHub in the past or other products like GitLab, and we'll explain what are the differences between Git and services such as GitHub and GitLab. We'll break out the architecture of what a Git process looks like. How do you go through and create forks and clones? How do you have collaborators being added into your projects? How do you go through the process of branching, merging, and rebasing your project? And what are the list of commands that are available to you in Git? Finally, I'll take you through a demo on how you can actually run Git yourself. And in this instance, use the software of Git against a public service such as GitHub. All right, let's talk a little bit about version control systems. So you may have already been using a version control system within your environment today. You may have used tools such as Microsoft's Team Foundation services, but essentially the use of a version control system allows people to be able to have files that are all stored in a single repository. So if you're working on developing a new program, such as a website or an application, you would store all of your version control software in a single repository. Now, what happens is that if somebody wants to make changes to the code, they would check out all of the code in the repository to make the changes, and then there would be an addendum added to that. So there would be the version 1 changes that you had, then the person would then later on check out that code, and then be a version 2 added to that code. And so you keep adding on versions of that code. The bottom line is that eventually you'll have people being able to use your code, and that your code will be stored in a centralized location. However, the challenge you run in is that it's very difficult for large groups to work simultaneously within a project. The benefits of a VCS system, a version control system, demonstrates that you're able to store multiple versions of a solution in a single repository. Now let's take a step at some of the challenges that you have with traditional version control systems and see how they can be addressed with distributed version control. So in a distributed version control environment, what we're looking at is being able to have the code shared across a team of developers. So if there are 2 or more people working on a software package, they need to be able to effectively share that code amongst themselves, so that they constantly are working on the latest piece of code. So a key part of a distributed version control system that's different to just a traditional version control system is that all developers have the entire code on their local systems, and they try and keep it updated all the time. It is the role of the distributed VCS server to ensure that each client, and we have a developer here, and developer here, and developer here, and each of those are clients, have the latest version of the software, and then that each person can then share the software in a peer-to-peer like approach. So that as changes are being made into the server of changes to the code, then those changes are then being redistributed to all of the development team. The tool to be able to do an effective distributed VCS environment is Git. Now, you may remember that we actually covered Git in a previous video, and we'll reference that video for you. So we start off with our remote Git repository, and people are making updates to the copy of their code into a local environment. That local environment can be updated manually and then periodically pushed out to the Git repository. So you're always pushing out the latest code changes you've made into the repository. And then from the repository, you're able to pull back the latest updates. And so your Git repository becomes the kind of the center of the universe for you. And then updates are able to be pushed up and pulled back from there. What this allows you to be able to accomplish is that each person will always have the latest version of the code. So what is Git? Git is a distributed version control tool used for source code management. So GitHub is the remote server for that source code management, and your development team can connect their Git client to that remote hub server. Git is used to track the changes of the source code and allows large teams to work simultaneously with each other. It supports a non-linear development because of thousands of parallel branches and has the ability to handle large projects efficiently. So let's talk a little bit about Git versus GitHub. So Git is a software tool, whereas GitHub is a service, and I'll show you how those two look in a moment. You install the software tool for Git locally on your system, whereas GitHub, because it is a service, it's actually hosted on a website. Git is actually the software that's used to manage different versions of source code, whereas GitHub is used to have a copy of the local repository stored on the service, on the website itself. Git provides command line tools that allow you to interact with your files, whereas GitHub has a graphical interface that allows you to check in and check out files. So let me just show you the two tools here. So here I am at the Git website, and this is the website you would go to download the latest version of Git. And again, Git is a software package that you install on your computer that allows you to be able to do version control in a peer-to-peer environment. For that peer-to-peer environment to be successful, however, you need to be able to store your files in a server somewhere. And typically, a lot of companies will use a service such as GitHub as a way to be able to store your files. So Git can communicate effectively with GitHub. There are actually many different companies that provide similar service to GitHub. GitLab is another popular service, but you also find that development tools such as Microsoft Visual Studio are also incorporating Git commands into their tools. So the latest version of Visual Studio Team Services also provides this same ability. But GitHub, it has to be remembered, is a place where we actually store our files and can very easily create public and shareable, is a place where we can store our files and create public shareable projects. You can come to GitHub and you can do a search on projects. You can see at the moment I'm doing a lot of work on blockchain, but you can actually search on the many hundreds of projects here. In fact, I think there's something like over 100,000 projects being managed on GitHub at the moment. That number is probably actually much larger than that. And so if you are working on a project, I would certainly encourage you to start at GitHub to see if somebody's already maybe done a prototype that they're sharing, or they have an open source project that they want to share that's already available in GitHub. Certainly if you're doing anything with Azure, you'll find that there are thousands, 45,000 Azure projects currently being worked on. Interestingly enough, GitHub was recently acquired by Microsoft, and Microsoft is fully embracing open source technologies. So that's essentially the difference between Git and GitHub. One is a piece of software, and that's Git, and one is a service that supports the ability of using the software, and that's GitHub. So let's dig deeper into the actual Git architecture itself. So the working directory is the folder where you are currently working on your Git project. And we'll do a demo later on where you can actually see how we can actually simulate each of these steps. So you start off with your working directory where you store your files, and then you add your files to a staging area where you are getting ready to commit your files back to the main branch on your Git project. You want to push out all of your changes to a local repository after you've made your changes, and these will commit those files and get them ready for synchronization with the service, and will then push your services out to the remote repository. An example of a remote repository would be GitHub. Later, when you want to update your code, before you write any more code, you would pull the latest changes from the remote repository so that your copy of your local software is always the latest version of the software that the rest of the team is working on. One of the things that you can do is, as you're working on new features within your project, you can create branches, you can merge your branches with the mainline code. You can do lots of really creative things that ensure that A, the code remains at very high quality, and B, that you're able to seamlessly add in new features without breaking the core code. So let's step through some of the concepts that we have available in Git. So let's talk about forking and cloning in Git. So both of these terms are quite old terms when it comes to development, but forking is certainly a term that goes way back, long before we had distributed CVS systems such as the ones that we're using with Git. To fork a piece of software is a particular open source project. You would take the project and create a copy of that project, but then you would then associate a new team and new people around that project. So it becomes a separate project in entirety. A clone, and this is important when it comes to working with Git, a clone is identical with the same teams and same structuring as the main project itself. So when you download the code, you're downloading an exact copy of that code with all the same security and access rights as the main code. And then you can then check that code back in, and potentially your code, because it is identical, could potentially become the mainline code in the future. Now, that typically doesn't happen. Your changes are the ones that merge into the main branch, but you do have that potential where your code could become the main code. With Git, you can also add collaborators that can work on the project, which is essential for projects particularly where you have large teams. This works really well when you have product teams where the teams themselves are self-empowered. You can do a concept what's called branching in Git. And so say, for instance, you are working on a new feature. That new feature and the main version of the project have to still work simultaneously. So what you can do is you can create a branch of your code so you can actually work on the new feature, whereas the rest of the team continue to work on the main branch of the project itself. And then later you can merge the two together. Pull from remote is the concept of being able to pull in services, software the team is working on from a remote server. And Git rebase is the concept of being able to take a project and re-establish a new start from the project. So you may be working on a project where there have been many branches and the team has been working for quite some time on different areas, and maybe you kind of losing control of what the true main branch is. You may choose to rebase your project. And what that means though is that anybody that's working on a separate branch will not be able to branch their code back into the mainline branch. So going through the process of a Git rebase essentially allows you to create a new start for where you're working on your project. So let's go through forks and clones. So you want to go through the process. So you want to go ahead and fork the code that you're working on. So let's use this scenario that one of your team wants to go ahead and add a new change to the project. The team member may say, yeah, go ahead and create a separate fork of the actual project. So what does that look like? So when you actually go ahead and create a fork of the repository, you actually go and you can take the version of the mainline branch, but then you take it completely offline into a local repository for you to be able to work from. and you can take the mainline code and you can then work on a local version of the code separate from the mainline branch. It's now a separate fork. Collaborators is the ability to have team members working on a project together. So if someone is working on a piece of code and they see some errors in the code that you've created, none of us are perfect at writing code. I know I've certainly made errors in my code. It's great to have other team members that have your back and can come in and check and see what they can do to improve the code. So to do that, you have to then add them as a collaborator. Now you would do that in GitHub. You can give them permission within GitHub itself. It's really easy to do, super visual interface that allows you to do the work quickly and easily. And depending on the type of permissions you want to give them, sometimes it can be very limited permissions. It may be just to be able to read the files. Sometimes it's being able to go in and make all the changes. You can go through all the different permission settings on GitHub to actually see what you can do. But you'll be able to make changes so that people can actually have access to your repository, and then you as a team can then start working together on the same code. Let's step through branching in Git. So suppose you're working on an application, but you want to add in a new feature. And this is very typical within a DevOps environment. So to do that, you can create a new branch and build a new feature on that branch. So here you have your main application on what's known as the master branch. And then you can then create a sub branch that runs in parallel, which has your feature. You can then develop your feature and then merge it back into the master branch at a later point in time. Now, the benefit you have here is that by default, we're all working on the master branch. So we always have the latest code. The circles that we have here on the screen show various different commits that have been made so that we can keep track of the master branch and then the branches that have come off which have the new features. And there can be many branches in Git. So Git keeps the new features you're working on in separate branches until you're ready to merge them back in with the main branch. So let's talk a little bit about that merge process. So you're starting with the master branch, which is the blue line here. And then here we have a separate parallel branch, which has the new features. So if we're to look at this process, the base commit of feature B is the branch. F is what's going to merge back into the master branch. And it has to be said there can be so many divergent branches, but eventually you want to have everything merge back into the master branch. Let's step through Git rebase. So again, we have a similar situation where we have a branch that's being worked in parallel to the master branch. And we want to do a Git rebase. So we're at stage C, and what we've decided is that we want to reset the project so that everything from here on out along the master branch is the standard product. However, this means that any work that's being done in parallel as a separate branch will be adding in new features along this new rebased environment. Now, the benefit you have by going through the rebase process is that you're reducing the amount of storage space that's required for when you have so many branches. It's a great way to just reduce your total footprint for your entire project. So Git rebase is the process of combining a sequence of commits to form a new base commit. And the primary reason for rebasing is to maintain a linear project history. When you rebase, you unplug a branch and replug it in on the tip of another branch. And usually you do that on the master branch, and that will then become the new master branch. The goal of rebasing is to take all the commits from a feature branch and put it together in a single master branch. It makes the project itself much easier to manage. Let's talk a little bit about pull from remote. Suppose there are two developers working together on an application. The concept of having a remote repository allows the two developers will be actually then checking in their code into a remote repository that becomes a centralized location for them to be able to store their code. It enables them to stay updated on the recent changes to the repository because they'll be able to pull the latest changes from that remote repository so that they are ensuring that as developers, they're always working on the latest code. So you can pull any changes that you have made to your forked remote repository to your local repository. The command to be able to do that is written here, and we'll go through a demo of how to actually do that command in a little bit. Good news is if there are no changes, you'll get a notification saying that you're already up to date. And if there is a change, it will merge those changes to your local repository and you get a list of the changes that have been made remotely. So let's step through some of the commands that we have in Git. So git init initializes a local Git repository on your hard drive. Git add adds one or more files to your staging area. Git commit -m commit message is a commit changes the git command, commits changes to head up. So the git command commits changes to your local staging area. Git status checks the status of your current repository and lists the files you have changed. Git log provides a list of all the commits made on your current branch. Git diff views the changes that you've made to the file. So you can actually have files next to each other and you can actually see the differences between the two files. Git push origin branch name, so the name of your branch command, will push the branch to the remote repository so that others can use it. And this is what you would do at the end of your project. Git config -global username will tell Git who you are by configuring the author name, and we'll go through that in a moment. Git config global user email will tell Git the author of by the email ID. Git clone creates a Git repository copy from a remote source. Git remote add origin server connects the local repository to the remote server and adds the server to be able to push to it. Git branch and then the branch name will create a new branch for you to create a new feature that you may be working on. Git checkout and then the branch name will allow you to switch from one branch to another branch. Git merge branch name will merge a branch into the active branch. So if you're working on a new feature, you're going to merge that into the main branch. A git rebase will reapply commits on top of another base tip. And git rebase will reapply commits on top of another base tip. And these are just some of the popular Git commands. There are some more, but you can certainly dig into those as you're working through using Git. So let's go ahead and run a demo using Git. So now we are going to do a demo using Git on our local machine and GitHub as the remote repository. For this to work, I'm going to be using a couple of tools. First, I'll have the deck open as we've been using up to this point. The second is I'm going to have my terminal window also available. And let me bring that over so you can actually see this. And the terminal window is actually running Git Bash as the software in the background, which you'll need to download and install. You can also run Git Bash locally on your Windows computer as well. And in addition, I'll also have the GitHub repository that we're using for Simplilearn already set up and ready to go. All right, so let's get started. So the first thing we want to do is create a local repository. So let's go ahead and do exactly that. So the local repository is going to reside in my development folder that I have on my local computer. And for me to be able to do that, I need to create a drive in that folder. So I'm going to go ahead and change the directory. So I'm actually going to be in that folder before I actually create and make the new folder. So I'm going to go ahead and change directory. And now I'm in the development directory. I'm going to go ahead and create a new folder. And that's gone ahead and created a new folder called Hello World. I'm going to move my cursor so that I'm actually in the Hello World folder. And now that I'm in the Hello World folder, I can now initialize this folder as a Git repository. So I'm going to use the git command init to initialize, and that's going ahead and initialize that folder. So let's see what's happened. So here I have my Hello World folder that I've created, and you'll now see that we have a hidden folder in there which is called .git. And if we expand that, we can actually see all of the different subfolders that Git repository will create. So let's just move that over a little bit so that we can see the rest of the work. And now if we check on our folder here, we actually see this is users Matthew development hello world.git, and that matches up with hidden folder here. So we're going to go ahead and create a file called readme.txt in our folder. So here is our hello world folder, and I'm going to go ahead and using my text editor, which happens to be Sublime, I'm going to create a file, and it's going to have in there the text hello world, and I'm going to call this one readme.txt. If I go to my hello world folder, you'll see that we have the readme.txt file actually in the folder. What's interesting is if I select the git status command, what it'll actually show me is that this file has not yet been added to the commits yet for this project. So even though the file is actually in the folder, it doesn't mean that it's actually part of the project. For us to do that, we actually have to go and select For us to actually commit the file, we have to go into our terminal window, and we can use the git status to actually read the files that we have there. So let's go ahead and use the git status command, and it's going to tell us that this file has not been committed. You can use this with any folder to see which files and subfolders haven't been committed. And what we can now do is we can go and actually add the readme file. So let's go ahead and we're just going to select git add. So the git command is add readme.txt. So that then adds that file into our main project, and we want to then commit those files into the main repository's history. And so to do that, we'll hit the git command commit, and we'll do a message in that commit, and this one will be first commit, and it has committed that project. What's interesting is we can now go back into readme file, and I can change this. So we can go hello git. Git is a very popular version control solution, and we'll save that. Now what we can do is we can actually go and see if we have made differences to the readme text. So to do that, we'll use the diff command for git. So we do git diff, and it gives us two releases. The first is what the original text was, which is hello world, and then what we have afterwards is what is now the new text in green, which has replaced the original text. So what we're going to do now is you want to go ahead and create an account on GitHub. We already have one. So what we're going to do is we're going to match the account from GitHub with our local account. So to do that, we're going to go ahead and select git config, and we're going to do dash, and it's going to be a global user name, and we're going to put in our username that we use for GitHub. In this instance, we're using the Simplilearn -GitHub account name. And under the GitHub account, you can go ahead and create a new repository name. In this instance, we call the repository hello-world. And what we want to do is connect the local GitHub account with the remote hello-world.git account. And we do that by using this command from Git, which is our remote connection. And so let's go ahead and type that in. Open this up so we can see the whole thing. So we're going to type in git remote add origin https github.com/Simplilearn-GitHub, and you have to get this typed in correctly when you're typing in the location hello-world.git. That creates the connection to your Hello World account. And now what we want to do is we want to push the files to the remote location using the git push command. Commit git push origin master. So we're going to go ahead and connect to our local remote GitHub. So I'm just going to bring up my terminal window again. And so let's select git remote, add origin, and we'll connect to the remote location, github.com/simplylearn-hello-world.git. Oh, we actually have already connected, so we're connected to that successfully. And now we're going to push the master, gish. So git push origin master, and everything is connected and successful. And if we go out to GitHub now, we can actually see that our file was updated just a few minutes ago. So what we can actually do now is we can go and fork a project from GitHub and clone it locally. So we're going to use the fork tool that's actually available on GitHub. Let me show you where that is located. And here is our branching tool. It's actually changed more recently with a new UI interface. And once complete, we'll be able to then pull a copy of that to our account using the fork's new HTTP URL address. So let's go ahead and do that. So we're going to go ahead and create a fork of our project. Now, to do that, you would normally go in, when you go into your project, you'll see that there are fork options in the top right-hand corner of the screen. Now, right now, I'm actually logged in with the default primary account for this project. So I can't actually fork the project as I'm working on the main branch. However, if I come in with a separate ID, and here I am, I have a different ID, and so I'm actually pretending I'm somebody else, I can actually come in and select the fork option and create a fork of this project. And this will take just a few seconds to actually create the fork. And there we are. We have gone ahead and created the fork. So you want to select clone or download with this. And so this is the, if I select, that'll actually give me the web address. I can actually show you what that looks like. I'll open up my text editor. Oops, that's not correct. I guess that is correct. So I'm going to copy that. And I can fork the project locally and clone it locally. I can change the directory, so I can create a new directory that I'm going to put my files in and then post in that content into that folder. So I can now actually have multiple versions of the same code running on my computer. I can then go into the forked content and use the patchwork command to actually, so I can create a copy of that code that we've just created, and we call it, that's a clone, and we can create a new folder that we're actually putting the work in. And we could, for whatever reason we wanted to, we could call this folder patchwork, and that would be maybe a new feature. And then we can then paste in the URL of the new directory that has the forked work in it. And now at this point, we've now pulled in and created a clone of the original content. And so this allows us to go ahead and fork out all of the work for our project onto our computer. So we can then develop our work separately. So now what we can actually do is we can actually create a branch of the fork that we've actually pulled in onto our computer. So we can actually then create our own code that runs in that separate branch. And so we want to check out the branch and then push the origin branch down to our computer. This will give us the opportunity to then add our collaborators. So we can actually then go over to GitHub and we can actually come in and add in our collaborators. And we will do that under settings and select collaborators. And here we can actually see we have different collaborators that have been added into the project, and you can actually then request people to be added via their GitHub name or by email address or by their full name. One of the things that you want to be able to do is ensure that you're always keeping the code that you're working on fully up to date by pulling in all the changes from your collaborators. You can create a new branch and then make changes and merge it into the master branch. To do that, you would create a folder, and then that folder in this instance would be called test. We would then move our cursor into the folder called test and then initialize that folder. So let's go ahead and do that. So let's create a new folder, and we're going to first of all change our root folder. We're going to go to development, and we're going to create a new folder. We call it test, and we're going to move into the test folder, and we will initialize that folder. And we're going to move some files into that test folder. Call this one test1, and then we're going to do file save as, and this one's going to be test2, and now we're going to commit those files. Git add, git add, and then we'll use the dot to pull in all files, and then git commit -m files committed. Make sure I'm in the right folder here. I don't think I was. And now that I'm in the correct folder, let's go ahead and git commit, and it's gone ahead and added those files, and so we can see the two files that were created have been added into the master. And we can now go ahead and create a new branch. We call this one git branch test _ branch. And let's go ahead and create a third file to go into that folder. This is file 3. We'll do file save as. We'll call this one test3.txt. And we'll go ahead and add that file. And do git add test3.txt. And we're going to move from the master branch to the test branch. Git check out test _ branch. And it switched to the test branch. And we'll be able to list out all of the files that are in that branch now. And we want to go through and merge the files into one area. So let's go ahead and we'll do git merge test _ branch. And it's, well, we've already updated everything, so that's good. So otherwise it would tell us what we would be merging. And now all the files are merged successfully into the master branch. There we go, all merged together. Fantastic. And so what we're going to do now is move from master branch to test branch. So git checkout test _ branch. And we can modify the files, the test3 file that we took out, and pull that file up. And we can now modify it. And we can then commit that file back in. And we've actually been able to then commit the file with one changes, and we've seen it's the text-free change that was made. And we can now go through the process of checking the file back in, switching back to the master branch, and ensuring that everything is in sync correctly. We may at one point want to rebase all of the work. It's kind of a hard thing you want to do, but it will allow you to allow for managing for changes in the future. So let's switch to it back to our test branch, which I think we're actually on. We're going to create 2 more files. Let's go to our folder here and let's go copy those. And that's created. We'll rename those tests 4 and 5. And so we now have additional files. And we're going to add those into our branch that we're working on. So we're going to go in and select git add -a, and we're going to commit those files. Git commit -a -m, adding 2 new files, and it's added in the 2 new files. So we have all of our files now. We can actually list them out, and we have all the files that are in the branch. And we'll switch then to our master branch. We want to rebase the master. So we do git rebase master, and that will then give us the command that everything is now completely up to date. And we can go git checkout master to switch to the master account. This will allow us to then continue through and rebase the test branch and then list all the files so they're all in the same area. So let's go git rebase test _ branch, and now we can list, and there we have all of our files listed in correct.
Maven. If we talk in the literal sense, Maven means accumulator of knowledge. Maven is a very powerful project management tool, or we can call it a build tool, that helps building, documenting, and managing a project. But before we move forward and dive deep into the basics of Maven, let's understand what is meant by the term build tool. A build tool takes care of everything for building a project. It generates a source code, generates documentation from a source code, it even compiles the source code and packages the compiled codes into jar of zip files. Along with that, the build tool also installs the packaged code in local repository, server repository, or central repository. Coming back to Maven, it is written in Java or C#, and it is based on Project Object Model or POM. Again, let's have a pause and understand what is meant by this term Project Object Model. A Project Object Model or POM is a building block in Maven. It is an XML file that contains information about the project and configuration details used by Maven to build a project. This file resides in the base directory of the project as pom.xml file. The POM contains information about the project and various configuration details. It also includes the goals and plugins used by Maven in a project. Maven looks for the POM in the current directory while executing a task or a goal. It reads the POM, gets the needed configuration information, and then runs the goal. Coming back, Maven is used to building and managing any Java-based project. It simplifies the day-to-day work of Java developers and helps them in their projects. Now, when we know the basics of Maven, let's have a look at some reasons to know why is Maven so popular and why are we even talking about it. So, let's have a look at the need for Maven. Maven, as by now we know, is popularly used for Java-based projects. It helps in downloading libraries or Java files used in the project. To understand the part of why do we use Maven or the need of Maven, let's have a look at some problems that Maven solved. The first problem is getting the jar files. In a project, getting the right jar files is a difficult task, where there could be conflicts in the versions of the two separate packages. However, it makes sure all the jar files are present in its repositories and avoid any such conflicting scenarios. The next problem it sorted was downloading dependencies. We needed to visit the official website of different software, which could be a tedious task. Now, instead of visiting individual websites, we could visit mvnrepository.com, which is a central repository of the jar files. Then Maven plays a vital role in the creation of the right project structure in servlets, struts, etc. Otherwise, it won't be executed. Then Maven also helps to build and deploy the project so that it may work properly. So the next point is what exactly Maven does. It makes the building of the project easy. The task of downloading the dependencies and jar files that were to be done manually can now be done automatically. All the information that is required to build the project is readily available now. Finally, Maven helps manage all the processes such as building, documenting, releasing, and other methods that play an integral part in managing a project. Now, when we know everything about Maven, let's look at some companies that use Maven. There are over 2,000 companies that use Maven today. The companies that use Maven are mostly located in the United States and in the computer science industry. Maven is also used in industries other than computer science, like information technology and services, financial service, banking, hospital and care, and much more. Some of the biggest corporations that use Maven are as follows. First we have Via Varejo, then comes Accenture, followed by JP Morgan Chase & Company, then comes Craft Base, and finally we have Red Hat.
Now Gradle is a kind of a build tool which can be used for the build automation performance, and it can be used for various programming languages. Primarily it's being used for the Java based applications. It's a kind of build tool which can help you to see that how exactly automatically you can prepare the builds, you can perform the automations. Earlier we used to do the build activity from the Eclipse, and we used to do it manually, right? But with the help of this build tool we are going to do it like automatically without any manual efforts as such here. There are like a lot of activities which we will be doing during the build process. Primarily there are different activities like compilations, linkage, packaging. These are the different tasks which we perform during the build process, so that we can understand that how the build can be done and we can perform the automations. This process also, it's kind of standardized, because again if you want to automate something, standards or a standard process is something which we require for that before being going ahead with that part. So that's the reason why we are getting this build tool, because this build tool helps us to do a standardization process to see that how the standards can be met and how we can proceed further with that part. Also, it's something which can be used for a variety of languages, programming languages. Java is the primary language for which we use the Gradle, but again other languages like Scala, Android, C++, Groovy, these are some of the languages for which we can use the same tool. Now it's actually using, like, it's referring to as a Groovy based domain specific language rather than XML, because Ant and Maven, these are the XML based build tools, but this one is not that dependent on XML. It's using the Groovy based domain specific language. DSL language is being used here. Right now, again, it's something which can be used to do the build. It can further on be used to perform the test cases automations also there, and then further on you can deploy to the Artifactory also that okay, I want to push the artifacts to the Artifactory, so that part also you can get it done over here. So primarily this tool is known for doing the build automations for the big and large projects, the projects in which the source code, the amount of source code and the efforts is more. So in that case, this particular tool makes sense. Now Gradle includes both the pros of Maven and Ant, but it removes the drawbacks or whatever the issues which we face during these two build tools. So it's helping us to remove all the cons which we face during the implementation of Ant and Maven, and again all the pros of Ant and Maven is implemented with this Gradle tool. Now let's see that why exactly this Gradle is used, because that's a very valid question, that what is the activity, like what is the reason why we use the Gradle. Because the first one is that it resolves issues faced on other build tools. That's a primary reason, because we are already having the tools like Maven and Ant which is available there, but primarily this Gradle tool is something which is removing all the issues which we are facing with the implementation of other tools. So these issues are getting removed as such. Second one is that it focuses on maintainability, performance and flexibility. So it's giving the focus on that how exactly we can manage the big large projects, and we can have flexibility that what different kind of projects I want to build. Today I want to build in different ways, tomorrow the source code modifies, gets added up, so I have the flexibility that I can change this build scripts, I can perform the automations. So a lot of flexibility is available which is being supported by this tool. And then the last one is like it provides a lot of features, a lot of plugins. Now this is one of the benefit which we get in the case of Maven also, that we get a lot of features. But again, when we talk about Gradle, then it provides a lot of plugins. Like let's say that normally in a build process we do the compilation of the source code, but sometimes let's say that we want to build an Angular or a Node.js application. Now in that case we may be involved in running some command line executions, some command line commands, just to make sure that yes, we are running the commands and we are getting the output. So there are a lot of features which we can use, like there are a lot of plugins which is available there, and we will be using those plugins in order to go ahead and in order to execute those build process and doing the automations. Now let's talk about the Gradle and Maven, because again when we talk about Maven, like it was like something which was primarily used for the Java, but again when we are talking about Gradle, so again it's just being used primarily for the Java here. But what is the reason that we prefer Gradle over the Maven? So what are the different reason for that? Let's talk about that part, because this is very important. We need to understand that what is the reason that Gradle is preferred as a better tool for the Java as compared to Maven when we talk about for the build automation here. Now the first one is that the Gradle using the Groovy DSL language, domain specific language, whereas the Maven is considered as a project management tool which is creating the POMs or XML format files. So it's being used for the Java project, but XML format is being used here. And on the other hand, Gradle is something which is not using the XML formats, and whatever the build scripts you're creating, that is something which is there in the Groovy based DSL language. And on the other hand, in the POM we have to create the XMLs, dependencies, whatever the attributes you are putting up in the Maven, that's something which is available there in the format of XML. The overall goal of the Gradle is to add functionality to a project, whereas the goal of the Maven is to to complete a project phase, like to work on different project phase, like compilation, test executions, then packaging, so then deploying to Artifactory. So these are all different phases which is available there into the Maven. But on the other hand, Gradle is all about adding the functionality, that how you want to have some particular features added up into the build scripts. In Gradle, there are, like, we usually specify that what are the different tasks we want to manage. So different tasks we can add up into the case of Gradle, and we can override those tasks also. In case of Maven, it's all about the different phases which is being happening over here, and it's in sequence manner. So these phases happens in the sequence order, that how exactly you can build up the sequence there. But in case of Gradle, you can have your own tasks, custom tasks also, and you can disrupt the sequence, and you can see that how the different steps can be executed in a different order. So Maven is something which is a phase mechanism there, but Gradle is something which is according to the features or the flexibilities. Now Gradle works on the tasks, whatever the task you want to perform, it works directly on those tasks there. On the other hand, Maven is something does not have any kind of inbuilt cache, so every time you are running the build, so separate things or the plugins and all this information gets loaded up, which takes definitely a lot of time. On the other hand, Gradle is something which is using its own internal cache so that it can make the builds a little bit faster, because it's not something which is doing the things from the scratch. Whatever the things is already being available in the cache, so it's just pick that part, and from there it will proceed further on the build automation. And that's the reason why Gradle performance is much faster as compared to Maven, because it uses some kind of a cache in there and then helps to improve the overall performance. Now let's talk about the Gradle installation, because this is a very important aspect to be done, because when we are doing the installation, we have to download the Gradle executables, right? So let's see that what are the different steps is involved in the process of the Gradle installation. So when we talk about the Gradle installation, so there are primarily 4 steps which is available. The very first one is that you have to check if the Java is installed. Now if the Java is not installed, so you can go to the Open JDK or you can go for the Oracle Java, so you can do the installation of the JDK on your system. So JDK 8 is something you can most commonly use nowadays, so you can install that. Once the Java is downloaded and installed, then you have to do the Gradle download Gradle there. Now once the Gradle binaries are executable or the zip file gets downloaded, so you can add the environment variables, and then you can validate if the Gradle installation is working fine as expected or not. So we will be doing the Gradle installation into our local systems and into the Windows platform, and we'll see that how exactly we can go for the installation of Gradle, and we'll see that what are the different versions we are going to install here. So let's go back to the system and see that how we can go for the Gradle installation. So this is the website of the JDK of a Java, Oracle Java. Now here you have different JDK, so from there you can do whatever the option you want to select, you can go with that. So JDK 8 is something which is most commonly used nowadays, like it's most comfortable or compatible version which is available. So in case you want to see that if the JDK is installed into your system, all you have to do is that you have to just say like Java -version, and that will give you the output that whether the Java is installed into your system or not. So in case my system the Java is installed, but if you really want to do the installation, you have to download the JDK installer from this website, from this Oracle website, and then you can proceed further on that part. Now once the JDK is installed, so you have to go for the Gradle installation, because Gradle is something which will be performing the build automations and all that stuff. So you have to download the binaries, like the zip file probably, in which we have the executables and all, and then we have to have some particular environment variables configured so that we will be able to have the system modified over there. So right now we have got like the prerequisites as in Java version installed. Now the next thing is that we have to install or download the executables. So in order to download the latest Gradle distribution, so you have to click on this one, right? Now over here there are different options, like you want to go for 6.7. now they're having like binary onlys or complete. We'll go for the binary onlys because we don't want to have the source, we just want the binaries and the executables. Now it's getting downloaded, it's around close to 100 MB of the installer which is there. Now we have to just extract into a directory, and then the same path we need to configure into the environment variable, so that in that way we will be able to see that how the Gradle executables will be running, and it will give the complete output to us over here in this case. So it may take some time, and once the particular modifications and the download is done, then we have to extract it, and once the extraction is done, so we will be able to go back and have some particular version or have the configurations established over there. So let's just wait for some time, and then we will be continuing with the environment variables like this one. So once the installation and the extraction is done, now we just have to go to the downloads where this one is downloaded. We have to extract it. Now extraction is required so that we can have the setup, like we can set up this path into our environment variables, and once the path is configured and established, we will be able to start further on that part on the execution. So meanwhile these files are getting extracted. Let's see. So we already got the folder structure over here, and we will see like we will give this path here. There is 2 environment variables we have to configure. One is the Gradle_home and one is the in the path variable. So we'll copy this path here. So meanwhile this is getting extracted, we can save our time and we can go to the environment variable. So we can right click on this one, properties. In there we have to go for the advanced systems settings, then environment variables. Now here we have to give it like Gradle underscore home. Now in this one we will not be giving it till the bin directory, so that only needs to be there where the Gradle is extracted. So we'll say okay, and then we have to go for the path variable where we will be adding up a new entry. In this one we will be putting up till the bin directory here, because the Gradle executable should be there when I'm running the Gradle command. So these two variables I have to configure, then okay, and okay. So this one is done. So now you have to just open the command prompt and see that whether the execution or the commands which you're running is completely successful or not. So meanwhile it's extracting all the executables and all those things. It will help us to understand that how the whole build process or how the build tools can be integrated over there. Now once the extraction is done, so you have to run like cmd Java version to check the version of the Java, and then the Gradle underscore version is what you're going to see. Check the version of the Gradle which is installed, and now you can see that it says that 6.7 version is being installed over here in this case. So that's the way that how we are going to have the Gradle installation performed into our particular system. So let's go back to the content. Let's talk about the Gradle core concepts here. Now in this one we are going to talk about what are the different core concepts of Gradle are all about. The very first one is the projects here. Now a project represents an item to be performed over here, to be done, like deploying an application to a staging environment, performing some build. So Gradle is something which is required. The projects, the Gradle project which you prepare is not having multiple tasks which is available there, which is configured, and all these tasks, all these different tasks needs to be executed into a sequence. Now sequence is again is a very important part, because again if the sequence is not met properly, then the execution will not be done in a proper order. So that's the very important aspect here. Tasks is the one in which is a kind of an entity in which we will be performing a series of steps. These tasks may be like compilation of a source code, preparing a jar file, preparing a web application archive file, or a ER file. Also we can have like in some tasks we can even publish our artifacts to the artifact tree, so that we can store those artifacts into a shared location. So there are different ways in which we can have this particular tasks executed. Now build scripts is the one in which we will be storing all this information. What are the dependencies, what are the different tasks we want to refer. It's all going to be present in the build.gradle file there. Build.gradle file will be having the information related to what are the different dependencies you want to download and you want to store there. So all these things will be a part of the build scripts. Now let's talk about the features of Gradle. What are the different features which we can use in case of Gradle here. There are different type of features which is available there. So let's talk about them one by one. So the very first one over here is the high performance. Then high performance is something which we can see that we already discussed, that in case you are using a large projects, so Gradle is something which is in better approach as compared to Maven because of the high performance which we are getting. It uses an internal cache which makes sure that you are using, like you are doing the builds faster, and that can give you a higher performance over there. Second one is the support. It provides the support. So it definitely provides a lot of support on how you can perform the builds, and it's being the latest tool which is available there. So the support is also quite good in terms of how you want to prepare the build, how you want to download the plugins, different plugin supports, and the dependencies information also there. Next one is multi-project build software. So using this one you can have multiple projects. In case in your repository you have multiple projects here, so all of them can be easily built up with the help of this particular tool. So it supports multiple projects to be built up using the same Gradle project and Gradle scripts. So that support is also available with this Gradle build tool. Incremental builds are also something which you can do with the help of Gradle. So if you have done only the incremental changes and you want to perform only the incremental build, so that can also be possible with the help of a Gradle here. The build scans, so we can also perform the build scans. So we can use some integrations with SonarQube and all, where we can have the scans done to the source code on understand on how the build happens or how the source code really happens on there. So that code scan or the build scans can also be performed with this one. And then it's a familiarity with Java. So for Java, it's something which is considered as an by default. Not even Java, in fact Android, which is also using the Java programming language, is using the particular Gradle over here, so that the build can be done and it can gain benefits out of that. So in all the manners, in all the different ways, it's basically helping us to see that how we can make sure that this tool can help us in providing a lot of features, and that can help us to make a reliable build tool for our Java based projects or any other programming based project here. Right, now let's see that how we can onboard a Java project with the Gradle here, and for that we have to go back, and Gradle is something which is already installed. We just have to create a directory where we can have like how we can perform some executions, we can prepare some build scripts, and we can have a particular execution of a Gradle build happened over there. So let's go back to the machine. Okay, so we are going to open the terminal here and we'll see that how we can create it. So first of all, I have to create a directory structure. Let's say that we'll say like Gradle -project. Now once the project is created, so we can go inside this directory. So to create some Gradle related projects and preparing the files. Now in this one, let's first create a particular one. So we will be saying like vi build.gradle. So in this one, we are going to put like two plugins we are going to use. So we are going to say like apply plugin Java, and then we are going to say like apply plugin application. So these two plugins we are going to use, and when we got this file over here in this one, so it shows like build.gradle, which is available there in this case. So two these files are available. Now if you want to learn like what are the different tasks, so you can run like Gradle tasks command over there. So Gradle task will help you know that what are the different tasks which is available over here by processing the build scripts and all. So this will definitely help you to understand on giving you the output. So here all the different tasks are being given, and it will help you to understand that what are the different tasks you can configure and you can work over here, just like jar files, clean and all that stuff, build, compile, then init is there, then all these different executions, assemble, then Java dog, then build, then check, test, all these different tasks are there. And if you really want to run the Gradle build, so you can run like Gradle clean to perform the clean activity, because right now you are doing like a build, so before that you can have a clean, and then you can run a specific command, or you can run the Gradle clean build, which will perform the cleanup also, and it will at the same time will have the build process also performed over there. So build and cleanup both will be executed over here, and what is the status, whether it's a success or it's a failure, that will be given back to you. Now in this case, in the previous one, if you see that when you ran the Gradle clean, it was only running one task, but when you go for the build process, when you run the Gradle clean build, it's going to give you a much more information. In fact, you can also give me further information, like you can have the -info flag also there, so that if you want to get the details about the different tasks which is being executed over here, so that also you're going to get over here in this one. So you just have to put like -info, and then all these steps will be given back to you, that how these tasks will be executed and the response will be there. So that's a way that how you can create a pretty much simple straightforward project in form of Gradle, which can definitely help you to run some couple of Gradle commands, and then you can understand that what are the basic commands you can run and how the configurations really works on there. Right, let's go back to the main content. Right, now let's move on to the next one. So in the next one, we are going to see that how we can prepare a Gradle build project in case of Eclipse. Now we are not using the local system, we are not directly creating the folders and the files here. We are actually using the Eclipse for performing creating a new Gradle project over here. So let's move on that part. Okay, so now the Eclipse is open, and I have opened in this one. The very first thing is that we have to do the Gradle plugin installation, so that we can create new projects on Gradle, and then we have to configure the path, that how the Gradle plugin can be configured on the preferences and all that stuff, and then we will be doing the build process. So the very first thing is that we have to go to the Eclipse marketplace. In there we have to search for Gradle. So once the search is done, it will show us the plugins related to Gradle. So we have to go for build ship Gradle integration. So we'll click on the install. It will proceed with installation. It will download it. In some cases maybe it's part of the Eclipse as in the ID, so you can go to the installed tab and you can see that also, that if this plugin is already installed or not. But in this case we are installing it, and once the installation is done, we just have to restart the specific once we have to restart this Eclipse so that the changes can be reflected. So it's downloading the Gradle here, and once that is installed, we will be able to use it over here in this case, in this scenario. So we have to just wait for that part. So still downloading the jar files. So once the jar file is done, it's now over the areas and downloaded. So after that we will be able to proceed further on that download aspect. So it's going to take some time to download it, and once it's done we will be able to proceed further. Now once the progress is done, so it's asking us for the restart now. So before that we just have to click on restart now, and then the Eclipse will be restarted altogether again here. So you can do it manually or you can go for that options. It just require a restart so that the new changes can be reflected over here. So the plugins can be activated and can be referenced here. Now we have to just put up like the the configuration where we can have the system. So we can go for the Gradle configuration. So we can go for Windows and then preferences. Now in this case we have to go for the ones in which the Gradle option is available there. So Gradle is what we are going to select. Now user home, the Gradle user home is what we need to use, right? So you want to go for the Gradle, you want to go for local installation. So all these options you can use. You can, if you go for the Gradle wrapper, then it will be downloading the Gradle locally and it is going to use the Gradle W or gradlew.bat file. But if you already have an installation locally, so you can prefer that also, right? Now in the previous demo we have already got the Gradle extracted, so we just have to go for the downloads. In the downloads already Gradle is available, so we are going to select that part here. So this is what we are going to select, right? So this represents that this is the directory structure in which we are having the mechanism. So you can either go for the build scan, so you can select the build scan also. So once this is enabled, then all the projects will be scanned and will be published, and it's in kind of additional option which is available. If you really want to disable it, you can disable it also, and you can go with this configuration also. So this is where the particular Gradle folder is being put over here in this case, and then we have to just click on apply, and we just have to click on apply and close. So with this one the particular execution is done. Now we will be going for the project creation, so you can right click over here or you can go to the file also. So here we are going to go for the project, and in this we are going to have a Gradle project. So Gradle project is what we are going to create here. And next, so we are going to say like Gradle project, and then next. So once that is done, so finish. So with this one, when you create the project, so what will happen that automatically there will be a folder structure will be available there, right? And there are some Gradle scripts which will also be created there. So we will be doing the modifications to there, and we'll see that how the particular Gradle build script looks like, and how we will be adding some couple of Selenium related dependencies, and we'll see that how we can have more and more dependencies added, and what will be the impact of those dependencies on the overall project. So that also it's very important aspect to be considered. So let this processing be happen over there. It's just creating, and some plugins and binaries are getting installed and getting downloaded. So we'll see that once the project is imported, completely executed over here and got created, we can extract that. Now if you see here, the particular option is available about the Gradle tasks, so you can extract it also, and you will be able to know that what are the different tasks which is available there. Let's see that in the build they are running like build. These are the different tasks which is happening inside the build process. So Gradle executions will be also available over here in this case, and Gradle tasks will be different. It will be represented over here in this one. So you just have to extract on the Gradle build project. Okay, so this is the library which is available. Now what happens that you will be able to have like settings.gradle. In this one you will be able to have like, okay, Gradle hyphen project is something which is available there in this one, so that's what I'm being referring. Then we have over here as in these folder structures which is created like source, main, Java. This is the one. Source, test, Java is the one which is available as in the folder structure, and source, test, resources are also available here. So the main source, main, resources are also available. Now in this case what happens that these are the dependencies, project and external, these are the different dependencies are available there. So let's see, let's add a dependency over here in this one in the build.gradle script and see that how we can do that. If we open build.gradle file, so you can see that these dependencies are there, like test implementation, JUnit is available there, right? And then we have a implementations of this one which is available. Now these jar files when you put up, it will automatically be added up as in part of this one, as in part of the particular dependencies over here, and which means that you don't have to store them as in within the repository, and automatically they can be happened over there. So let's open a dependency page. So we will be going to Maven repository where we will be opening a dependency link. So this is the dependency link here. So Selenium-Java is available, and it can give you the dependency for all the different options. Now we have for Maven, this is the one, and for Gradle, this is the one here. So we have to just copy this one, and we have to use it as a dependency. So this is the group, and this is the name and the version which we are using here. Now we have copied this one, so we will go back to the Eclipse. So here we have to just put that dependency, and we have to just save it. So this is something which is providing like Selenium dependencies which is available. So now we have to just refresh the project. So right click over here, then you will be able to see the options in the Gradle saying that refresh Gradle project. Now once the moment you do that, so you will be able to do like for the first time, maybe it will take some time to download all the dependencies which is related to Selenium, but after that you will be able to see like the dependencies will be simply added up over here in this case. So you can see that all the Selenium related dependencies are added up. For any reason, if you comment these ones and you say like synchronize again, so you will see that all the dependencies which you are adding up from this Selenium from the Selenium perspective will be gone back again. So this is the way that how you can keep on adding the dependencies which is required for preparing your build for your source code, and from there you will be able to proceed further on the execution part. So that's the best part about this Gradle here. So that's a way that how we are going to prepare a Gradle project within the Eclipse, and now you can keep on adding like the source code in this one, and that's the way that how the code base will be added up over here. So when we talk about the Gradle installation, so there are primarily 4 steps which is available. The very first one is that you have to check if the Java is installed. Now if the Java is not installed, so you can go to the Open JDK or you can go for the Oracle Java, so you can do the installation of the JDK on your system. So JDK 8 is something you can most commonly use nowadays, so you can install that. Once the Java is downloaded and installed, then you have to do the Gradle download Gradle there. Now once the Gradle binaries are executable or the zip file gets downloaded, so you can add the environment variables, and then you can validate if the Gradle installation is working fine as expected or not. So we will be doing the Gradle installation into our local systems and into the Windows platform, and we'll see that how exactly we can go for the installation of Gradle, and we'll see that what are the different versions we are going to install here. So let's go back to the system and see that how we can go for the Gradle installation. So this is the website of the JDK of Java, Oracle Java. Now here you have different JDK, so from there you can do whatever the option you want to select, you can go with that. So JDK 8 is something which is most commonly used nowadays, like it's most comfortable or compatible version which is available. So in case you want to see that if the JDK is installed into your system, all you have to do is that you have to just say like Java -version, and that will give you the output that whether the Java is installed into your system or not. So in case my system the Java is installed, but if you really want to do the installation, you have to download the JDK installer from this website, from this Oracle website, and then you can proceed further on that part. Now once the JDK is installed, so you have to go for the Gradle installation, because Gradle is something which will be performing the build automations and all that stuff. So you have to download the binaries like the zip file probably in which we have the executables and all, and then we have to have some particular environment variables configured so that we will be able to have the system modified over there. So right now we have got like the prerequisites as in Java version installed. Now the next thing is that we have to install or download the executables. So in order to download the latest Gradle distribution, so you have to click on this one. Right now over here there are different options, like you want to go for 6.7. now it's having like binary onlys or complete. We'll go for the binary onlys because we don't want to have the source, we just want the binaries and the executables. Now it's getting downloaded, it's around close to 100 MB of the installer which is there. Now we have to just extract into a directory, and then the same path we need to configure into the environment variable, so that in that way we will be able to see that how the Gradle executables will be running, and it will give the complete output to us over here in this case. So it may take some time, and once the particular modifications and the download is done, then we have to extract it, and once the extraction is done, so we will be able to go back and have some particular version or have the configurations established over there. So let's just wait for some time, and then we will be continuing with the environment variables like this one. So once the installation and the extraction is done, now we just have to go to the downloads where this one is downloaded. We have to extract it. Now extraction is required so that we can have the setup, like we can set up this path into our environment variables, and once the path is configured and established, we will be able to start further on that part and on the execution. So meanwhile these files are getting extracted. Let's see. So we already got the folder structure over here, and we will see like we will give this path here. There is two environment variables we have to configure. One is the Gradle underscore home, and one is the in the path variable. So we'll copy this path here. So meanwhile this is getting extracted, we can save our time and we can go to the environment variable. So we can right click on this one, properties. In there we have to go for the advanced systems settings, then environment variables. Now here we have to give it like Gradle underscore home. Now in this one we will not be giving it till the bin directory, so that only needs to be there where the Gradle is extracted. So we'll say okay, and then we have to go for the path variable where we will be adding up a new entry. In this one we will be putting up till the bin directory here, because the Gradle executable should be there when I'm running the Gradle command. So these two variables I have to configure, then okay, and okay. So this one is done. So now you have to just open the command prompt and see that whether the execution or the commands which you're running is completely successful or not. So meanwhile it's extracting all the executables and all those things. It will help us to understand that how the whole build process or how the build tools can be integrated over there. Now once the extraction is done, so you have to run like cmd java version to check the version of the Java, and then the Gradle underscore version is what you're going to see, that check the version of the Gradle which is installed, and now you can see that it says that 6.7 version is being installed over here in this case. So that's the way that how we are going to have the Gradle installation performed into our particular system.
With the first topic, that is the birth of Selenium. Selenium was primarily created by Jason Huggins in 2004. Jason, an engineer at ThoughtWorks, was working on a web application that needed to be tested frequently. He realized that the repeated manual testing of the application is becoming inefficient. So he created a JavaScript language that automatically controlled the browser's actions. This program was named JavaScript Test Runner. After he realized that his idea of automating the web applications has a lot of potential, he made the JavaScript Test Runner open source, and it was later renamed as Selenium Core. So we know that Jason was the person who initially created Selenium. But then we must also know that Selenium is a collection of different tools, and since there are different tools, there will be several developers too. To be exact about the number of different tools, there are 4 different tools that have their own creators. Let's have a look at all of them. The first tool is the Selenium Remote Control, or the Selenium RC, that was created by Paul Hammond. Then comes Selenium Grid, that was developed by Patrick Lightbody. The third tool is the Selenium IDE, that was created by Shinya Kasatani, and the fourth tool, that is the Selenium WebDriver, was created by Simon Stewart. We shall be learning about all these tools in great detail as we move forth in our video. First, let's have a look at what is Selenium. Selenium is a very popular open source tool that is used for automating the tests carried on the web browsers. There may be various programming languages like Java, C#, Python, etc. that could be used to create Selenium test scripts. This testing that is done using Selenium tool is referred to as Selenium testing. We must understand that Selenium allows the testing of web applications only. We can neither test any computer software nor any mobile application using Selenium. Selenium is composed of several tools with each having its own specific role and serving its own testing needs. Moving forward, let's have a look at the features of Selenium, which will help us understand the reason behind its widespread popularity. So here we have a set of features of Selenium. Selenium is an open source and portable framework that has a playback and record feature. It is one of the best cloud-based testing platform and supports various OS and languages. It can be integrated with several testing frameworks and supports parallel test execution. We will be talking about all these features in detail as we move forward. So here, the first feature that we have is open source and portable framework. This feature states that Selenium is an open source and portable framework for testing web applications. In addition to that, Selenium commands are categorized in terms of different classes, which make it easier to understand and implement. The second feature is the playback and record feature. The feature states that the tests can be authorized without learning a test scripting language with the help of playback and record features. The next feature says that Selenium is a cloud-based testing platform. Selenium is a leading cloud-based testing platform that allows testers to record their actions and export them as a reusable script with a simple to understand and easy to use interface. Moving forth, the next feature states that Selenium supports various operating systems, browsers, and programming languages. The tool supports programming languages such as C#, Java, Python, PHP, Ruby, Perl, and JavaScript. If we talk about the operating systems, then Selenium supports operating systems like Android, iOS, Windows, Linux, Mac, and Solaris. And the tool also supports various browsers like Google Chrome, Mozilla Firefox, Internet Explorer, Edge, Opera, Safari, etc. Then the next feature we have is the integration with testing frameworks. Selenium can be well integrated with testing frameworks like TestNG for application testing and generating reports. And also, Selenium can be integrated with frameworks like Ant and Maven for source code compilation. The last feature in our list is the parallel test execution. Selenium enables parallel testing, which reduces time and increases the efficiency of the tests. Selenium requires fewer resources as compared to other automation testing tools. Now, let's move further and get to know different Selenium tools. By now we know that there are 4 different tools that come under the Selenium suite. The 4 tools are Selenium Remote Control, Selenium Grid, Selenium IDE, and Selenium WebDriver. We shall have a look at these 4 tools in detail one after the another. Beginning with Selenium Remote Control. Selenium Remote Control enables the writing of automated web applications in languages such as Java, C#, Perl, Python, and PHP to build complex tests such as reading and writing files, querying a database, and emailing the test results. Selenium RC was a sustainable project for a very long time before Selenium WebDriver came into existence, and hence Selenium RC is hardly in use today, as the WebDriver offers more powerful functionalities. The second tool we shall see is the Selenium Grid. Selenium Grid is a smart proxy server that enables the running of tests in parallel on several machines. This is made possible when the commands are routed to the remote web browser instances and one server acts as the hub. The hub here is responsible for conducting several tests on multiple machines. Selenium Grid makes cross-browser testing easy as a single test can be carried on multiple machines and browsers altogether, making it easy to analyze and compare the results. Here, there are two main components of Selenium Grid, Hub and the node. Hub is a server that accepts the access request from the WebDriver client, routing the JSON test commands to the remote drivers on nodes. And here, the node refers to the remote device that consists of a native OS and a remote WebDriver. It receives the request from the hub in the form of a JSON test commands and executes them using the WebDriver. Moving forth, the third tool is the Selenium IDE. If you want to begin with the Selenium IDE, it needs no additional setup except installing the extension of your browser. It provides an easy-to-use tool that gives instant feedbacks. Selenium IDE records multiple locators for each element it interacts with. If one locator fails during the playback, the others will be tried until one is successful. The IDE makes the test debugging easier with features like setting breakpoints and pausing exceptions. Through the use of the run command, you can reuse one test case inside one another. And also, Selenium IDE can be extended through the use of plugins. They can introduce new commands to the IDE or integrate with a third-party service. The last and the fourth tool in the Selenium suite is the Selenium WebDriver. Selenium WebDriver is the most critical component of the Selenium Tools suite that allows cross-browser compatibility testing. The WebDriver supports various operating systems like Windows, Mac, Linux, Unix, etc. It provides compatibility with a range of languages including Python, Java, and Perl. Along with it, it provides supports different browsers like Chrome, Firefox, Opera, Safari, and Internet Explorer. The Selenium WebDriver completes the execution of test scripts faster when compared to other tools, and also it provides compatibility with iPhone driver, HTML unit driver, and Android driver. Now, after you know about the tools, the question arises which tool to choose. So in the next topic, we shall see different factors on the basis of which we may decide which tool would be more suitable for us. Here, we shall have a look at the reasons why one should choose that particular tool. We shall begin with Selenium Remote Control. Selenium Remote Control or Selenium RC should be chosen to design a test using a more expressive language than Selenese. Selenese is a set of Selenium commands that are used to test our web applications. Then the Selenium RC might be chosen to run tests against different browsers on different operating systems. The RC may be chosen to deploy tests across multiple environments using Selenium Grid. It helps in testing the applications against a new browser that supports JavaScript and web applications with complex AJAX-based scenarios. Now, the second tool for which we shall see the reasons are Selenium Grid. Selenium Grid, as we learnt in the reasons for Selenium RC, is used to run Selenium RC scripts in multiple browsers and operating systems simultaneously. The grid is used to run a huge test suite that needs to be completed at the earliest possible time. Now comes the third tool. The third tool is Selenium IDE. Selenium IDE is used to learn about concepts on automated testing and Selenium. These concepts include Selenese commands such as type, open, click and wait, assert, verify, etc. The concepts also include locators such as ID, name, XPath, CSS selector, etc. Selenium IDE enables the execution of customized JavaScript code using run script and exporting test cases in several different formats. The IDE is used to create tests with a limited amount of knowledge in programming, and these test cases and test suites can be exported later to RC or WebDriver. Now finally, let's have a look at the reasons to choose a last tool, that is Selenium WebDriver. Selenium WebDriver uses a certain programming language in designing a test case. The WebDriver is used to test applications that are rich in Ajax-based functionalities execute.
So this is what we're going to be covering in this session. We're going to cover what life is like before using Jenkins and the issues that Jenkins specifically addresses. Then we'll get into what Jenkins is about and how it applies to continuous integration and the other continuous integration tools that you need in your DevOps team. Then specifically, we'll deep dive into features of Jenkins and the Jenkins architecture. And we'll give you a case study of a company that's using Jenkins today to actually transform how their IT organization is operating. So let's talk a little bit about life before Jenkins. Let's see this scenario. I think it's something that maybe all of you can relate to. As developers, we all write code and we all submit that code into a code repository, and we all keep working away, writing our unit tests, and hopefully we're running our unit tests. But the problem is that the actual commits that actually get sent to the code repository aren't consistent. You as a developer may be based in India, you may have another developer that's based in the Philippines, and you may have another team lead that's based in the UK, and another development team that's based in North America. So you're all working at different times, and you have different amounts of code going into the code repository. There's issues with the integration, and you're kind of running into a situation that we like to call development hell, where things just aren't working out and there's just lots of delays being added into the project, and the bugs just keep mounting up. The bottom line is the project is delayed. And in the past, what we would have to do is we'd have to wait until the entire software code was built and tested before we could even begin checking for errors. And this just really kind of increased the amount of problems that you'd have in your project. The actual process of delivering software was slow. There was no way that you could actually iterate on your software, and you just ended up with just a big headache with teams pointing fingers at each other and blaming each other. So let's jump into Jenkins and see what Jenkins is and how it can address these problems. So Jenkins is a product that comes out of the concept of continuous integration that you may have heard of as power developers, where you'd have two developers sitting next to each other coding against the same piece of information. What they were able to do is to continuously develop their code and test their code and move on to new sections of code. Jenkins is a product that allows you to expand on that capacity to your entire team. So you're able to submit your codes consistently into a source code environment. So there are two ways in which you can do continuous delivery. One is through nightly builds and one is through continuous. So the approach that you can look at continuous delivery is modifying the legacy approach to building out solutions. So what we used to do is we would wait for nightly builds, and the way that our nightly builds would work and operate is that as code developers, we would all run and have a cutoff time at the end of the day that was consistent around the world, that we would put our codes into a single repository. And at night, all of that code would be run and operated and tested to see if there were any changes, and a new build would be created. And that would be referred to as the nightly build. With continuous integration, we're able to go one step further. We're able to not only commit our changes into our source code, but we can actually do this continuously. There's no need to race and have a team get all of their code in at an arbitrary time. You can actually do a continuous release, because what you're doing is you're putting your tests and your verification services into the build environment. So you're always running cycles to test against your code. This is the power that Jenkins provides in continuous integration. So let's dig deeper into continuous integration. So the concept of continuous integration is that as a developer, you're able to pull from a repository the code that you're working on, and then you'll be able to then at any time submit the code that you're working on into a continuous integration server. And the goal of that continuous integration server is that it actually goes ahead and validates and passes any tests that a tester may have created. Now, if on the continuous integration server a test isn't passed, then that code gets sent back to the developer, and the developer can then make their changes. It allows the developer to actually do a couple of things. It allows the developer not to break the build, and we all don't want to break the builds that are being created, but it also allows the developer not to actually have to run all of the tests locally on their computer. Running tests, particularly if you have a large number of tests, can take up a lot of time. So if you can push that service off to another environment, like a continuous integration server, it really improves the productivity of your developer. What's also good is that if there are any code errors that have come up that may be beyond just the standard CI test, so maybe there's a code, the way that you write your code isn't consistent, those errors can then be passed on easily from the tester back to the developer too. The goal from doing all of this testing is that you're able to release and deploy, and your customer is able to get new code faster, and when they get that code, it simply just works. So let's talk a little bit about some of the tools that you may have in your continuous integration environment. So the cool thing with working with continuous integration tools is that they are all open source, or at least the ones that we have listed here are all open source. There are some that are private, but typically you'll get started with open source tools, and it gives you the opportunity to understand how you can accelerate your environment quickly. So Bamboo is a continuous integration tool that specifically runs multiple builds in parallel for faster compilation. So if you have multiple versions of your software that runs on multiple platforms, this is a tool that really allows you to get that up and running super fast so that your teams can actually test how those different builds would work for different environments. And this has integration with Ant and Maven and other similar tools. So one of the tools you're going to need is a tool that allows you to automate the software build, test, and release process. And BuildBot is that open source product for you. Again, it's an open source tool, so there's no license associated with this. So you can actually go in and you can actually get the environment up and running, and you can then test for and build your environment and create releases very quickly. So BuildBot's also written in Python, and it does support parallel execution jobs across multiple platforms. If you're working specifically on Java projects that need to be built and tested, then Apache Gump is the tool for you. It makes all of those projects really easy. It makes all the Java projects easier for you to be able to test with API level and functionality level testing. So one of the popular places to actually store code and create versioning of your code is GitHub, and it's a service that's available on the web, just recently acquired by Microsoft. If you are storing your projects in GitHub, then you'll be able to use Travis Continuous Integration, or Travis CI, and it's a tool designed specifically for hosted GitHub projects. And so finally, we're covering Jenkins, and Jenkins is a central tool for automation for all of your projects. Now, when you're working with Jenkins, sometimes you'll find that there's documentation that refers to a product called Hudson. Hudson is actually the original version of the product that finally became Jenkins, and it was acquired by Oracle. When that acquisition happened, the team behind Hudson was a little concerned about the direction that Oracle may potentially go with Hudson, and so they created a hard fork of Hudson that they renamed Jenkins, and Jenkins has now become that open source project. It is one of the most popular and continuously contributed projects that's available as open source, so you're always getting new features being added to it. It's a tool that really becomes the center for your CI environment. So let's jump into some of those really great features that are available in Jenkins. So Jenkins itself is really comprised of 5 key areas around easy installation, easy configuration, plugins, extensibility, and distribution. So as I mentioned, for the easy installation, Jenkins is a self-contained Java program, and that allows it to run on most popular operating systems, including Windows, Mac OS, and Unix. You can even run it on Linux. It really isn't too bad to set up. It used to be much harder than it is today. The setup process has really improved. The web interface makes it really easy for you to check for any errors. In addition, you have great built-in help. One of the things that makes tools like Jenkins really powerful for developers and continuous integration teams and your DevOps teams as a whole, when you have plugins that you can then add in to extend the base functionality of the product. Jenkins has hundreds of plugins. And you can go and visit the Update Center and see which other plugins that would be good for your DevOps environment. Certainly check it out. There's just lots of stuff out there. In addition to the plugin architecture, Jenkins is also extremely extensible. The opportunity for you to be able to configure Jenkins to fit in your environment is almost endless. Now, it's really important to remember that you are extending Jenkins, not creating a custom version of Jenkins. And that's a great differentiation because the core foundation remains as the core Jenkins product. The extensibility can then be continued with newer releases of Jenkins. So you're always having the latest version of Jenkins and your extensions mature with those core foundation. The distribution and the nature of Jenkins makes it really easy for you to be able to have it available across your entire network. It really will become the center of your CI environment, and it's certainly one of the easier tools and more effective tools for DevOps. So let's jump into the standard Jenkins pipeline. So when you're doing development, you start off and you're coding away on your computer. The first thing you have to do when you're working in the Jenkins pipeline is to actually commit your code. Now, as a developer, this is something that you're already doing, or at least you should be doing. You're committing your code to a Git server or to an SVN server or similar type of service. So in this instance, you'll be using Jenkins as the place for you to commit your code. Jenkins will then create a build of your code, and part of that build process is actually going through and running through tests. And again, as a developer, you're already comfortable with running unit tests and writing those tests to validate your code. But there may be additional tests that Jenkins is running. So for instance, as a team, you may have a standard set of tests for how you actually write out your code so that each team member can understand the code that's been written. And those tests can also be included in the testing process within the Jenkins environment. Assuming everything passed the tests, you can then get everything placed in a stage and release ready environment within Jenkins. And finally, you're getting ready to deploy or deliver your code to a production environment. Jenkins is going to be the tool that helps you with your server environment to be able to deploy your code to the production environment. And the result is that you're able to move from a developer to production code really quickly. This whole process can be automated. Rather than having to wait for people to actually test your codes or going through a nightly build, you're looking at being able to commit your code and go through this testing process and release process continuously. As an example, companies Etsy will release up to 50 different versions of their website every single day. So let's talk about the architecture within Jenkins that allows you to be so effective at applying a continuous delivery DevOps environment. So the server architecture really is broken up into two sections. On the left-hand side of the section, you have the code the developers are doing and submitting that code to a source code repository. And then from then, Jenkins is your continuous integration server. And it will then pull any code that's being sent to the source code repository and will run tests against it. It will use a build service such as Maven to actually then build the code. And at every single stage that we have that Jenkins manages, there are constant tests. So for instance, if a build fails, that feedback is sent right back to the developers so that they can then change their code so that the build environment can run effectively. The final stage is to actually execute specific test scripts. And these test scripts can be written in Selenium. So it's probably good to mention here that both Maven and Selenium are plugins that run in the Jenkins environment. So before we were talking about how Jenkins can be extended with plugins, Maven and Selenium are just two very popular examples of how you can extend the Jenkins environment. The goal to go through this whole process, again, it's an automated process, is to get your code from the developer to the production server as quickly as possible, have it fully tested, and have no errors. So it's probably important at this point to mention one piece of information around the Jenkins environment, that if you have different code builds that need to be managed and distributed, this will require that you need to have multiple builds being managed. Jenkins itself doesn't allow for multiple files and builds to be executed on a single server. You need to have a multiple server environment with running different versions of Jenkins for that to be able to happen. So let's talk a little bit about the master-slave architecture within Jenkins. So what we have here is an overview of the master-slave architecture within Jenkins. On the left-hand side is the remote source code repository, and that remote source code repository could be GitHub, or it could be Team Foundation Services, or the new Azure DevOps code repository, or it could be your own Git repository. The Jenkins server acts as the master environment on the left-hand side, and that master environment can then push out to multiple other Jenkins slave environments to distribute the workload. So it allows you to run multiple builds and tests and production environments simultaneously across your entire architecture. So Jenkins slaves can be running the different build versions of the code for different operating systems, and the server master is controlling how each of those builds operate. So let's step into a quick story of a company that has used Jenkins very successfully. So here's a use case scenario. Over the last 10 or 15 years, there has been a significant shift within the automotive industry where manufacturers have shifted from creating complex hardware to actually creating software. We've seen that with companies such as Tesla, where they are creating software to manage their cars. We see the same thing with companies such as General Motors with their OnStar program. And Ford just recently have rebranded themselves as a technology company rather than just an automotive company. What this means, though, is that the software within these cars is becoming more complex and requires more testing to allow more capabilities and enhancements to be added to the core software. So Bosch is a company that specifically ran into this problem, and their challenge was that they wanted to be able to streamline the increasingly complex automotive software by adopting continuous integration and continuous delivery best practices, with the goal of being able to delight and exceed the customer expectations of the end user. So Bosch has actually used CloudBees, which is the enterprise Jenkins environment. So to be able to reduce the number of manual steps such as building, deploying, and testing, Bosch has introduced the use of CloudBees from Jenkins. And this is part of the enterprise Jenkins platform. It has significantly helped improve the efficiencies throughout the whole software development cycle, from automation, stability, and transparency, because Jenkins becomes a self-auditing environment. Now, the results have been tangible. Previously, it took 3 days before a build process could be done, and now it's taken that same 3-day process and reduced it to less than 3 hours. That is significant. Large-scale deployments are now kept on track and have expert support, and there is clear visibility and transparency across the whole operations through using the Jenkins tools.
Now, what is the purpose of Jenkins here? Now, Jenkins is normally a kind of a CI tool which we use for performing the build automations and the test cases automation there. It's one of the open source tool which is available there, and one of the most popular CI tool also available into the market. Now, this tool makes it easier for the developers to integrate the changes to the project here. So we can easily integrate the changes, and whatever the modifications we want to manage, we will be able to do that with the help of Jenkins. Now, Jenkins also achieves the continuous integration with the help of couple of plugins. Each and every tool which you want to integrate have its own plugins which is available there. For example, you want to integrate Maven. We have a Maven plugin in Jenkins which you can install, you can configure. In that case, you will be able to use the Maven there. Now, you can deploy the Maven to build tool onto the Jenkins server, and then you can prepare or you can configure any number of Maven jobs in case of Jenkins. So what exactly the Maven or the Jenkins really do is, the Maven when integrates with Jenkins through the particular plugin, so you can able to automate the builds, because for automation the build you require some integration with the Maven, and that integration is what we are getting from the Maven plugin. So in Jenkins, you have to install the Maven plugin, and once the plugin is installed, so what you can do is that you can proceed with the configurations, you can proceed with the setup, and this particular plugin can help you to build out some of the Java based projects which is available there in the Git repositories. And once that is done, you will be able to go ahead and you will be able to process a complete integration of Maven within Jenkins. Right, so let's see that how we can go for the integration. Now I have already installed the Maven onto the Linux virtual machine which we are using. So using the apt utility or using the yum utility, you can actually download the Jenkins package and the Maven package onto the server, onto the virtual machine. And now I'm going to proceed further with the plugin installation and the configuration of a Maven project. So I have a GitHub repository which is having a Maven project, Maven source code and the Mavenized test cases over there. So let's log into the Jenkins and see that how it works. So this is the Jenkins interface which we have over here. Now in this one, what we can do is that we can create some Maven jobs over here, and once those jobs are created, we will be able to do a custom build onto this Jenkins. So first of all, we have to install the particular plugin here. For that, we have to go to the Manage Jenkins. In Manage Jenkins, you have the Manage Plugins option there. So you have to click on that. Now here you will be having different tabs like updates, available, installed, advanced. All these different tabs are available there. So what you can do is that you can click on the available one. When you go to the available tab, so what will happen that here you can actually put up that what exactly plugin you want to fetch here. So I can put a plugin called Maven. Now you can see that the very first one, the Maven integration tool, is available. So I'm going to select that particular plugin and click on download now and install after restart. Now once that is done, so what will happen that the plugin will be downloaded, but in order to reflect the changes, we have to do a couple of restart. Now for that, you don't have to go to the virtual machine. You have the option here itself that will allow you to do the restart over here when you click on this button. So you check this option and say that restart Jenkins when the installation is done. So what will happen that the installation will be automatically attempted whenever the particular plugin installation is completed here. So you just have to refresh the page again, and you will be able to see that the particular Jenkins is being processed as such here. Right, so you can see that the screen is coming up that Jenkins is restarting. So it will take a couple of 5 to 6 seconds to do the restart and the login screen to come up again over there. You can do the refresh also if you feel. Automatically it will be reloaded once the Jenkins is ready, but sometimes we have to refresh it so that we can get the screen over there. So once the login is done, so my Maven integration is done. So next thing which I will be doing is that I will be creating a Maven related project. So I'm going to put the admin user and the password. So whatever the user and password you have created, so you are going to put that so that you will be able to log into the Jenkins portal. Now this is the Jenkins which is available here. So all you have to do is that you have to click on create a new job or new item. So both the option is pretty much same only. So here you will be able to see a Maven project here. So I'm going to select like Maven build. That's the name which I'm going to give here, and the Maven project I'm going to select here and then press OK. Now here you will be providing the first of all the repository from which you will be checking out the source code. Now I can have a discard old builds over here. So if I feel that I want to have like a log rotation, so all the previous builds should be deleted. So I'm just saying that dates to keep build should be 10 over here, and the number of builds which I need to keep over here is 20. You can adjust these settings according to your requirement, but over here we are doing a kind of configurations which we are trying to do a lot of configurations and settings here. So these are the particular settings which we are looking forward as such over here. So now we are going to have the log rotation here. So we can have it like how many days we want to keep and how many number of builds we want to keep here. So both the values we are providing over here. And then now I'm going to put the git integration here, like the repo URL. So I have this repository here in which I have the Java source code and some particular unit test cases, and I also have the particular source code, and it's kind of a Maven project. So that's what I'm trying to clone over over here with the help of this plugin. So this plugin will download this repository, it will clone it onto the Jenkins server, and then depending on our integration with Maven, the Maven build will be triggered here. So now I'm going to process with the Maven here. So you can see here that it's saying that Jenkins needs to know that where the Maven is installed, because that Maven version it needs to configure, it needs to process on that part. So I'll just do the save over here, and or I can click on this tool configuration. So I'll just save or do the apply, click on this tool configuration here. Now here you have the options like where you can have the JDK installation, but what happens that since Jenkins is running there, so JDK is automatically installed. So in the tools configuration you don't have to put the JDK configuration, but at least for the Maven configurations you have to provide that where exactly the Maven is available there. So I'm just saying that Maven 3 I want to process, and the latest Maven Apache web server I want to configure here. So I just want to have, like, I just want to save this setting so that it will be automatically download the latest version, Apache 3.6.3 version there, and that same should be utilized over here in this case. Now I'm just going to the Maven build configuration here and click on the configure part. So these Git repository is available here, and in the build step it automatically builds up that what Maven environment you want to select. So you see that previously, since I did not configure my Maven environment, so it was throwing an error, but once I have configured that I have to download it during the build process or before the build, that utility should be downloaded. So instead of doing the physical installation of Maven on the server, what I have chosen over here is that I have selected the particular version, like I have selected that particular 3.6.3 version should be installed for the Maven purposes over here. Now once that is done, I'm going to put the particular steps over here. You can have it like clean install, you can have clean compile test, clean test, or test alone you can give. It's just a part of the setup or the goals which you want to configure here. It by default says that pom.xml file is the current one in the current directory you need to refer. You need to pick on that one. What it's up to you only that how you want to configure and how you want to process as such these information. So according to your requirement, you can say that okay, I just want to go for these particular goals, and you can say like save over here. The particular configuration will be saved. Now you can just click on the build now, and you will be able to see that the first of all the git clone will happen, and then the desired Maven executable will be the build tool will be configured, and according to that it will be processed here. So you can see here that the Maven is getting downloaded, it's getting configured here, and once it's configured, because I have explained over there that 3.6.3 version I have to select, so that specific version will be configured and will be picked up over here. Now even if you don't have the Maven installed on the physical machine on which the Jenkins is running, still you will be able to do the processing using this particular component here. So you can see here that we have some particular test cases executed, and in the end we are able to get a particular artifacts also there. Since I did not call upon the package or install goal, that's the reason why the particular artifacts was not generated, var file or jar file, whatever the packaging mode is available at POM level. But still what happens that my test cases do gets executed, and that's what I have got over here in this case. So this is a kind of a mechanism where we feel that how we can configure a Git repository. Once the Git repository is configured, you are going to integrate the Maven plugin. In the Maven plugin, you are going to configure in the tools configuration that this and so version I want to configure to run my build. And once that is done, after that you just have to trigger the build and click on the build now option, and once that is done, you will be able to get a particular full-fledged build or compilation happened onto the Jenkins, and this log will give you the complete details that what are the different steps which has happened on this one.
So let's take a little scenario of a developer and a tester before you had the world of Docker. A developer would actually build their code and then they send it to the tester, but then the code wouldn't work on their system. The code doesn't work on the other system due to the differences in computer environments. So what could be the solution to this? Well, you could go ahead and create a virtual machine to be the same of the solution in both areas. But we think Docker is an even better solution. So let's kind of break out what the main big differences are between Docker and virtual machines. As you can see between the left and the right hand side, both look to be very similar. What you'll see, however, is that On the Docker side, what you'll see as a big difference is that the guest OS for each container has been eliminated. Docker is inherently more lightweight, but provides the same functionality as a virtual machine. So let's step through some of the pros and cons of a virtual machine versus Docker. So first of all, a virtual machine occupies a lot more memory space on the host machine. In contrast, Docker occupies significantly less memory space. The boot up time between both is very different. Docker just boots up faster. The performance of the Docker environment is actually better and more consistent than the virtual machine. Docker is also very easy to set up and very easy to scale. The efficiencies, therefore, are much higher with a Docker environment versus a virtual machine environment. And you'll find it is easier to port Docker across multiple platforms than a virtual machine. Finally, the space allocation between Docker and a virtual machine is significant. When you don't have to include the guest OS, you're eliminating a significant amount of space, and the Docker environment is just inherently smaller. So after Docker, as a developer, you can build out your solution and send it to a tester. And as long as we're all running in the Docker environment, everything will work just great. So let's step through what we're going to cover in this presentation. We're going to look at the DevOps tools and where Docker fits within that space. We'll examine what Docker actually is and how Docker works. And then finally, we'll step through the different components of the Docker environment. So what is DevOps? DevOps is a collaboration between the development team and the operation team, allowing you to continuously deliver solutions and applications and services that both delight and improve the efficiency of your customers. If you look at the Venn diagram that we have here, on the left-hand side we have development, on the right-hand side we have operation, and then there's a crossover in the middle, and that's where the DevOps team sits. If we look at the areas of integration between both groups, developers are really interested in planning, code, building, and testing, and operations want to be able to efficiently deploy, operate, and monitor. When you can have both groups interacting with each other on these 7 key elements, then you can have the efficiencies of an excellent DevOps team. So planning and code base, we use tools like Git and Gira. For building, we use Gradle and Maven. Testing, we use Selenium. The integration between dev and ops is through tools such as Jenkins. And then the deployment operation is done with tools such as Docker and Chef. Finally, Nagios is used to monitor the entire environment. So let's step deeper into what Docker actually is. So Docker is a tool which is used to automate the deployment of applications in a lightweight container so the application can work efficiently in different environments. Now, it's important to note that the container is actually a software package that consists of all the dependencies required to run the application. So multiple containers can run on the same hardware. The containers are maintained in isolated environments. They're highly productive, and they're quick and easy to configure. So let's take an example of what Docker is by using a house that may be rented for someone using Airbnb. So in the house, there are 3 rooms and only 1 cupboard and kitchen. And the problem we have is that none of the guests are really ready to share the cupboard and kitchen, because every individual has a different preference when it comes to how the cupboard should be stocked and how the kitchen should be used. This is very similar to how we run software applications today. Each of the applications could end up using different frameworks. So you may have a framework such as Rails, Perfect, and Flask, and you may want to have them running for different applications for different situations. This is where Docker will help you run the applications with the suitable frameworks. So let's go back to our Airbnb example. So we have 3 rooms and a kitchen and cupboard. How do we resolve this issue? Well, we put a kitchen and cupboard in each room. We can do the same thing for computers. Docker provides the suitable frameworks for each different application. And since every application has a framework with a suitable version, this space could also then be utilized for putting in software and applications that And since every application has its own framework and suitable version, the area that we had previously stored for a framework can be used for something else. Now we can create a new application, and in this instance a fourth application that uses its own resources. You know what? With these kinds of abilities to be able to free up space on the computer, it's no wonder Docker is the right choice. So let's take a closer look to how Docker actually works. So when we look at Docker and we call something Docker, we're actually referring to the base engine, which actually is installed on the host machine that has all the different components that run your Docker environment. And if we look at the image on the left-hand side of the screen, you'll see that Docker has a client-server relationship. There is a client installed on the hardware. There is a client that contains the Docker product, and then there is a server which controls how that Docker client is created. The communication that goes back and forth to be able to share the knowledge on that Docker client relationship is done through a REST API. And this is fantastic news because that means that you can actually interface and program that API. So we look here in the animation, we see that the Docker client is constantly communicating back to the server information about the infrastructure, and it's using this REST API as that communication channel. The Docker server then will check out the requests and the interaction necessary for it to be the Docker daemon, which runs on the server itself, will then check out the interaction and the necessary operating system pieces needed to be able to run the container. Okay, so that's just an overview of the Docker engine, which is probably where you're going to spend most of your time. But there are some other components that form the infrastructure for Docker. Let's dig into those a little bit deeper as well. So what we're going to do now is break out the four main components that comprise of the Docker environment. The four components are as follows: the Docker client and server, which we've already done a deeper dive on, Docker images, Docker containers, and the Docker registry. So if we look at the structure that we have here, on the left-hand side, you see the relationship between the Docker client and the Docker server. And then we have the REST API in between. Now, if we start digging into that REST API, particularly the relationship with the Docker daemon on the server, we actually have our other elements that form the different components of the Docker ecosystem. So the Docker client is accessed from your terminal window. So if you are using Windows, it's going to be PowerShell. On Mac, it's going to be your terminal window. And it allows you to run the Docker daemon and the registry service. When you have your terminal window open, so you can actually use your terminal window to create instructions on how to build and run your Docker images and containers. If we look at the images part of our registry here, we actually see that the image is really just a template with the instructions used for creating the containers which you use within Docker. The Docker image is built using a file called the Docker file. And then once you've created that Docker file, you'll store that image in the Docker Hub or registry. And that allows other people to be able to access the same structure of a Docker environment that you've created. The syntax of creating the image is fairly simple. It's something that you'll be able to get your arms around very quickly. And essentially what you're doing is you're creating the option of a new container. You're identifying what the image will look like, what are the commands that are needed, and the arguments for within those commands. And once you've done that, you have a definition for what your image will look like. So if we look here at what the container itself looks like, is that the container is a standalone executable package which includes applications and their dependencies. It's the instructions for what your environment will look like. So you can be consistent in how that environment is shared between multiple developers, testing units, and other people within your DevOps team. Now, the thing that's great about working with Docker is that it's so lightweight that you can actually run multiple Docker containers in the same infrastructure and share the same operating system. This is its strength. It allows you to be able to create those multiple environments that you need for multiple projects that you're working on. Interestingly though, within each container, that container creates an isolated area for the applications to run. So while you can run multiple containers in an infrastructure, each of those containers are completely isolated. They're protected so that you can actually control how your solutions work there. Now, as a team, you may start off with 1 or 2 developers on your team, but when a project starts becoming more important and you start adding in more people to your team, you may have 15 people that are offshore, you may have 10 people that are local, you may have 15 consultants that are working on your project. You have a need for each of those developers or each person on your team to have access to that Docker image. And to get access to that image, we use the Docker registry, which is an open source server-side service for hosting and distributing the images that you have defined. You can also use Docker itself as its own default registry and Docker Hub. Now, something that has to be very in mind though is that for publicly shared images, you may want to have your own private images, in which case you would do that through your own registry. So once again, public repositories can be used to host the Docker images, which can be accessed by anyone. And I really encourage you to go out to Docker and see the other Docker images that have been created, because there may be tools there that you can use to speed up your own development environments. Now, you will also get to a point where you start creating environments that are very specific to the solutions that you are building. And when you get to that point, you'll likely want to create a private repository so you're not sharing that knowledge with the world in general. Now, the way in which you connect with the Docker registry is through simple pull and push commands that you run through terminal window to be able to get the latest information. So if you want to be able to build your own container, what you'll start doing is using the pull commands to actually pull the image from the Docker repository. And the command line for that is fairly simple. In terminal window, you would write docker pull, and then you put in the image name and any tags associated with that image and use the command pulls. So in your terminal window, you would actually use a simple line of command once you've actually connected to your Docker environment. And that command will be docker pull with the image name and any associated tags around that image. What that will then do is pull the image from the Docker repository, whether that's a public repository or a private one. Now, in reverse, if you want to be able to update the Docker image with new information, you do a push command where you would take the script that you've written about the Docker container that you define and push it to the repository. And as you can imagine, the commands for that are also fairly simple. In terminal window, you would write docker push the image name, any associated tags, and then that would then push that image to the Docker repository. Again, either a public or a private repository. So if we recap, the Docker file creates a Docker image that's using the build commands. A Docker image then contains all of the information necessary for you to be able to execute the project. Using the Docker image, any user can run the code in order to create a Docker container. And once a Docker image is built, it's uploaded to a registry or to a Docker Hub where it can be shared across your entire team. And from the Docker Hub, users can get access to the Docker image and build their own new containers. So let's have a look at what we have in our current environment. So today, when you actually have your standard machine, you have the infrastructure, you have the host operating system, and you have your applications. And then when you create a virtual environment, what you're actually doing is you're actually creating virtual machines, but those virtual machines actually are now sitting within a hypervisor solution that sits still on top of your host operating system and infrastructure. And with a Docker engine, what we're able to do is we're able to actually reduce significantly the different elements that you would normally have within a virtualized environment. So we're able to get rid of the bins and so we're able to get rid of the guest OS, and we're able to eliminate the hypervisor environment. And this is really important as we actually start working and creating environments that are consistent, because we want to be able to make it so that it's really easy and stable for the environment that you have within your dev and ops environment. Now, critical is getting rid of that hypervisor element. It's just a lot of overhead. So let's have a look at a container as an example. So here we actually have a couple of examples. On the right hand side, we have different containers. We have one container that's running Apache Tomcat with Java. A second container is running SQL Server in a Microsoft.NET environment. The third container is running Python with MySQL. These are all running just fine within the Docker engine and sitting on top of a host OS, which could be Linux. It really could be any host OS within a consistent infrastructure. And you're able to have a solution that can be shared easily amongst your teams. So let's have a look at an example that you'd have today if a company is doing a traditional Java application. So you have your developers working in JBoss on his system and he's coding away and he has to get that code over to a tester. Now, what will happen is that tester will then typically in your traditional environment then have to install JBoss on their machine and get everything running and hopefully set up identically to the developer. Chances are they probably won't have it exactly the same, but they'll try and get it as close as possible. And then at some point, you want to be able to test this within your production environment, so you send it over to a system administrator who would then also have to install JBoss on their environment as well. Yeah, this just seems to be a whole lot of duplication. So why go through the problem of installing JBoss 3 times? And this is where things get really interesting, because the challenge you have today is that it's very difficult to almost impossible to have identical environments if you're just installing software locally on devices. The developer's probably got a whole bunch of development software that could be conflicting with the JBoss environment. The tester has similar testing software but probably doesn't have all the development software, and certainly the system administrator won't have all the tools that the developer and tester have, their own tools. And so what you want to be able to do is kind of get away from the challenge you have of having to do local installations on 3 different computers. And in addition, what you see is that this uses up a lot of effort, because when you're having to install software over and over again, you just keep repeating doing really basic foundational challenges. So this is where Docker comes in, and Docker is the tool that allows you to be able to share environments from one group to another group without having to install software locally on a device. You install all of the code into your Docker container and simply share the container. So in this presentation, we're going to go through a few things. We're going to cover what Docker actually is, and then we're going to dig into the actual architecture of Docker and kind of go through what Docker container is and how to create a Docker container. And then we'll go through the benefits of using Docker containers and then the commands, and finalize everything out with a brief demo. So what is Docker? So Docker is, as you'd expect, because all the software that we cover in this series is an open source solution, and it is a container solution that allows you to be able to containerize all of the necessary files and applications needed to run the solution that you're building. So you can share it from different people in your team, whether it's a developer, tester, or system administrator. And this allows you to have a consistent environment from one group to the next. So let's kind of dig into the architecture so you understand why Docker runs effectively. So the Docker architecture itself is built up of 2 key elements. There is the Docker client, and then there is a REST API connection to a Docker daemon, which actually hosts the entire environment. Within the Docker host and the Docker daemon, you have your different containers, and each one has a link to a Docker registry. The Docker client itself is a REST service, so as you'd expect, a REST API that sends command line to the Docker daemon through a terminal window or command line interface window. And we'll go through some of these demos later on so you can actually see how you can actually interact with Docker. The Docker daemon then checks the request against the Docker components and then performs the service that you're requesting. Now, the Docker image itself, all it really is a collection of instructions used to create a container. And again, this is consistent with all the DevOps tools that we have. The DevOps tools that we're looking to use throughout this series of videos are all environments that can be scripted. And this is really important because it allows you to be able to duplicate and scale the environments that you want to be able to build very quickly and effectively. The actual container itself has all of the applications and the dependencies of those applications in one package. You kind of think of it as a really effective and efficient zip file. It's a little bit more than that, but it's one file that actually has everything you need to be able to run all of your solutions. The actual Docker registry itself is an environment for being able to host and distribute different Docker images among your team. So say for instance you had a team of developers that were working on multiple different solutions. So say you have a team of developers and you have 50 developers and they're working on 5 different applications. You can actually have the applications themselves, the containers, shared in the Docker registry. So each of those teams at any time check out and have the latest container of that latest image of the code that you're working on. So let's dig into what actually is in a container. So the important part of a Docker container is that it has everything you need to be able to run the application. It's like a virtualized environment. It has all your frameworks and your libraries, and it allows the teams to be able to build out and run exactly the right environment that the developer intended. What's interesting though is the actual applications then will run in isolation, so they're not impacting other applications that using dependencies on other libraries or files outside of the container. Because of the architecture, it really uses a lot less space, and because it's using less space, it's a much more lightweight architecture, so the files, the actual folder itself is much smaller. It's very secure, highly portable, and the boot up time is incredibly fast. So let's actually get into how you would actually create a Docker container. So the Docker container itself is actually built through command line, and it's built of a file and Docker image. So the actual Docker file is a text file that contains all the instructions that you would need to be able to create that Docker image. And then we'll actually then create all of the project code within inside of that image. Then the image becomes the item that you would share through the Docker registry. You would then use the command line, and we'll do this later on, select Docker run and then the name of the image to be able to easily and effectively run that image locally. And again, once you've created the Docker image, you can store that in the Docker registry, making it available to anybody within your network. So something to bear in mind is that Docker itself has its own registry called Docker Hub, and that is a public registry, so you can actually go out and see other Docker images that have been created and access those images. As your own company, you may want to have your own private repository, so you want to be able to go ahead and either do that locally through your own repository, or you can actually get a licensed version of Docker Hub where you can actually then share those files. Now, something that's also very interesting to know is that you can have multiple versions of a Docker image. So if you have a different version control, different release versions, and you want to be able to test and write code for those different release versions because you may have different setups, you can certainly do that within your Docker registry environment. Okay, so let's go ahead and we're going to create a Docker image using some of our basic Docker commands. And so there are essentially really, kind of just two commands that you're going to be looking for. One is the build command, and another one is to actually put it into your registry, which is a push command. So if you want to get an image from a Docker registry, then you want to use the pull command, and a pull command simply pulls the image from the registry, in this example using nginx as our registry, and we can actually then pull the image down to our test environment on our local machine. So we're actually running the container within our Docker application on a local machine. We're able to then have the image run exactly as it would in production. And then you can actually use the run command to actually use the Docker image on your local machine. So just a few interesting tidbits about the Docker container. Once the container is created, a new layer is formed on top of the Docker image layer. It's called the container layer. Each container has a separate read-write container layer, and any changes made in that Docker container is then reflected upon the particular container layer. And if you want to delete the container layer also gets deleted as well. So, why would using Docker and containers be of benefit to you? Well, some of the things that are useful is that containers have no external dependencies for the applications they run. Once you actually have the container running locally, it has everything it needs to be able to run the application. So there's no having to install additional pieces of software, such as the example we gave with JBoss at the beginning of the presentation. The containers are really lightweight, so it makes it very easy to share the containers amongst your teams, whether it's a developer, whether it's a tester, whether it's somebody on your operations environment. It's really easy to share those containers amongst your entire team. Different data volumes can be easily reused and shared among multiple containers. And again, this is another big benefit, and this is a reflection of the lightweight nature of your containers. The container itself also runs in isolation, which means that it is not impacted by any dependencies you may have on your own local environment. So it's a completely sandboxed environment. So some of the questions you might ask is, can you run multiple containers together without the need to start each one individually? And you know what? Yes, you can with Docker Compose. Docker Compose allows you to run multiple containers in a single service. And again, this is a reflection on the lightweight nature of containers within the Docker environment. So we're going to end our presentation by looking at some of the basic commands that you'd have within Docker. So we have here on the left-hand side, we have a Docker container and then the command for each item. We're actually going to go ahead and use some of these commands in the demo that we're going to do after this presentation. You'll see that in a moment. But just, some of the basic commands we have are committing the Docker image into the container. Kill is a standard kill command to terminate one or more of the running containers so they stop working. Then restart those containers. But certainly you can look at all of the commands here and try them out for yourself. So we're going to go ahead and start a demo of how to use the basic commands to run Docker. So to do this, we're going to open up terminal window or command line, depending whether you're running Linux, PC, or Mac. And we're going to go ahead, and the first thing we want to do is see what our Docker image lists are. So we can go sudo docker images, and this will give us, well, first we'll enter in our password, so let's go enter that in. And this will now give us a list of our Docker images. And here are the Docker images that have already been created in the system. And we can actually go ahead and actually see the processes that are actually running. So I'm going to go ahead and open up this window a little bit more, but this will show you the actual processes and the containers that we actually have. And so on the far left-hand side, you see under names, we have Learn, Simplilearn, b_cool. These are all just different ones that we've been working on. So let's go ahead and create a Docker image. So we're going to do sudo docker run -d -p 0.0.0.0 :80:80 Ubuntu, and this will allow us to go ahead and run an Ubuntu image, and this will run the latest image. And what we have here is a hash number, and this hash number is a unique name that defines the container that we've just created, and we can go ahead and we can check to make sure that the container actually is present. So we're going to do sudo docker.ps, and this actually shows on there. So it's not in a running state right now, but that doesn't mean that we don't have it. So let's list out all the containers that are both running and in the exit state. So let's do sucker ps-a, and this lists all the containers that I have running on my machine. And this shows all the ones that have been in the running state and in the exit state. And here we see one that we just created about a minute ago, and it's called Learn. And these are all running Ubuntu, and this is the one that we had created just a few seconds ago. Let's open it up, and there we go. So let's change that to that new Docker container to a running state. So scroll down, and we're going to type sudo docker run -it -name my. So this is going to be the new container name. It's going to be my Docker. So this is how we name our Docker environment. And we'll put in the image name, which is Ubuntu. And -bin -bash. And it's now in our root, and we'll exit out of that. So now we're going to go ahead and start the new my Docker container. So sudo docker start my, and we'll get the container image, which will be my Docker, return, and that started that Docker image. And let's go ahead and check against the other running Docker images to make sure it's running correctly. So sudo docker ps, and there we are. Underneath name on the right hand side, you actually see my Docker along with the other Docker images that we created. And it's been running for 13 seconds. Quite fast. So we want to rename the container. Let's use the command sudo docker rename we can take another Docker image. Let's grab this one and we'll put it in rename, and we'll rename, and we'll put in the old container name, which is image, and then we'll put in the new container name, and let's call it purple. So now the container image that had previously been called image is now called purple. So we do sudo docker ps to list all of our Docker images, and if we scroll up, and there we go, purple. How easy is that to rename an image? And we can go ahead and use this command if we want to stop a container. So we're going to write sudo docker stop, and then we'll have to put in the container name, and we'll put in my Docker, the container that we originally created, and that image has now stopped. And let's go ahead and prove that. We're going to list out all the Docker images, and what you see is that it's not listed in the active images. It's not on the list on the far right hand side. But if we go ahead and we can list out all of the Docker images, so you actually see it's still there as an image, it's just not in an active state, it's what's known as in an exit state. So here we go. And there's my Docker, it's in an exited state. So that happened 27 seconds ago. So if we want to remove a container, we can use the following command. So sudo docker rm for remove my Docker, and that will remove it from the exited state. And we're going to go ahead and we're going to double check that. And yep. Yep. It's not listed there under exited state anymore. It's gone. And there we go. That's where it used to be. All right, let's go back. So if we want to exit a container in the running state, so we do sudo kill and then the name of the container. I think one of them is called yellow. Let's just check and see if that's going to kill it. Oops, no, I guess we don't have one called yellow. So let's find out the name of a container that we actually have. So sudo docker kill. Oh, we're going to list out the ones that are running. Oh, okay, there we go. Yellow isn't in that list, so let's take Simplilearn. And so we can actually go ahead and let's write sudo docker kill Simplilearn. And that will actually kill an active Docker container. Boom, there we go. And we list out all the active containers. You can actually see now that the Simplilearn container is not active anymore. And these are all the basic commands for Docker container.
The field of DevOps has grown exponentially over the past few years, and it's no surprise why. DevOps is a set of practices and tools that aims to break down the silos between development and operations team and streamline the software delivery process. By doing so, DevOps enables organizations to deliver high-quality software faster and more efficiently than ever before. So if you're interested in pursuing a career in DevOps, then this video on how to choose DevOps as a career is for you, with the proper roadmap on how to get started with it. Also, do not forget to subscribe to our YouTube channel and hit the bell icon to never miss an update from Simplilearn. So without any further ado, let's get started. First is to understand the role of a DevOps professional. Before diving into the specifics of how to become a DevOps professional, it's essential to understand the roles and responsibilities of a DevOps professional. A DevOps professional is typically responsible for designing, implementing, and maintaining the infrastructure, automation tools, and processes required for the efficient delivery of software. This includes collaborating with development teams to integrate automation into the software development process, setting up and maintaining the infrastructure required for the software delivery pipeline, such as servers, databases, and network systems, developing and implementing automation scripts to improve the efficiency of software delivery process, continuously monitoring and analyzing the software delivery process to identify and resolve bottlenecks and improve efficiency, ensuring that the software delivery process adheres to industry best practices and regulatory requirements. So now that you understand the roles and responsibilities of a DevOps professional, let's take a look at the roadmap to become a DevOps professional. So first is to learn the basics of software development. To be an effective DevOps professional, it's essential to have a good understanding of software development processes, including programming languages, software development methodologies, and version control tools. You can start by learning programming languages like Python, Java, or Ruby. Well, a DevOps Engineer course will prepare you for a career in DevOps technologies. Through this DevOps Engineer course, you will learn to review deployment methodologies, CI/CD pipelines, observability, and use DevOps tools like Git, Docker, and Jenkins with this DevOps Engineer certification. You can check out the link for this course in the description. Following that, learn about infrastructure and operations as a DevOps professional. You will be responsible for managing infrastructure, including servers, databases, and network system. So it's essential to have a good understanding of infrastructure and operations. This includes learning about servers, operating systems, network protocols, and storage systems. Then explore about automation tools and cloud services. Automation is a critical part of DevOps. Learning automation tools such as Ansible, Puppet, or Chef can help you streamline the software delivery process and improve efficiency. Most organizations today use cloud services to deliver software. Learning cloud services such as AWS, Azure, or GCP can help you design and implement cloud architecture that are efficient and scalable. Well, to help you with learning DevOps and cloud services, Simplilearn has to offer Azure DevOps Solution Expert Master's Program to help you become an industry-ready professional. In this course, you will learn to plan smarter, collaborate better, and ship faster with a set of modern development services. The link for this course is mentioned in the description. Do check them out. Once done with skilling, you need to gain experience and get certified as discussed before. The best way to gain experience in DevOps is to work on real-world projects. This can be achieved through internships, volunteering for open source projects, or even taking on small projects on your own. This will allow you to put your theoretical knowledge into practice and gain hands-on experience. Along with it, there are various certification programs available, such as the DevOps Institute Certification Program, AWS Certification DevOps Engineer, and Microsoft Azure DevOps Solutions Certification. Once you have gained experience and acquired the necessary skills, it's time to start looking for job opportunities. There are various job titles in DevOps, such as DevOps Engineer, Site Reliability Engineer, Automation Engineer, and Release Engineer. In top hiring companies in the field include Amazon, Google, Microsoft, IBM, and many others.
Now let's understand what is DevOps. DevOps is like a teamwork approach for making computer programs better and faster. It combines the work of software developers and the operation team. The goal is to help them work together and use tools that speed up the process and make fewer mistakes. They also keep an eye on the programs and fix problems early. This way, businesses can release programs faster, with few errors, and everyone works better together. If you want to learn more about this, then check Postgraduate Program in DevOps to understand from the basics to advanced concepts. This postgraduate program in DevOps is crafted in partnership with Caltech CTME. This comprehensive course aligns your expertise with industry benchmarks. Experience our innovative blended learning, merging live online DevOps certification sessions with immersive labs for practical mastery. Advance your career with hands-on training that meets industry demands. Alright, now let's move on to the first question of DevOps interview question, which is, what do you know about DevOps? So think of a DevOps like teamwork in the IT world. It's become really important because it helps teams work together smoothly to make computer programs faster and with fewer mistakes. Imagine a soccer team. Everyone works together to win the game. DevOps is similar. It's when computer developers and operations people team up to make software better. They start working together from the beginning, when they plan what the software will be like, until they finish and put it out for people to use. This teamwork makes sure things go well and the software works great. So this was about DevOps. Now moving on to the second question, which is how is DevOps different from Agile methodology? DevOps is like a teamwork culture where the people who create the software and the people who make it work smoothly join forces. This helps in always improving and updating the software without any big breaks. Agile is a way of making softwares that's like taking small steps towards instead of big jumps. It's about releasing small parts of the software quickly and getting feedback from the users. This helps in solving any issues or differences between what users want and what developers are making. So you can answer this question in this way. Alright, moving on to the third question, which is what are the ways in which a build can be scheduled/run in Jenkins? So as you can see, there are 4 ways: by source code management commits, second is after the completion of other builds, third is scheduled to run at a specified time, and fourth one is manual build requests. So if the interviewer asks, then you can answer these 4 ways in which a build can be scheduled in Jenkins. Alright, now the fourth question is what are the different phases in DevOps? So the various phases of DevOps lifecycle are as follows. So as you can see, first is plan. So initially there should be a plan for the type of application that needs to be developed. Getting a rough picture of the development process is always a good idea. Then code. The application is coded as per the end user requirements. Then there is build. Build the application by integrating various codes formed in previous steps. After that there is test. This is the most crucial step of the application development. Test the application and rebuild if necessary. Then there is integrate. So multiple codes from different programmers are integrated into one. After integrate there is deploy. So code is deployed into a cloud environment for further usage. It is ensured that any new changes do not affect the functioning of a high traffic website. After that there is operate. So operations are performed on the code if required. Then there is monitor. Application's performance is monitored. Changes are made to meet the end user requirements. So these all were the different phases of DevOps. And here we have explained each one of these. You can go through it, and if the interviewer have asked you this question, you can answer it in a similar way. Alright, now moving on to the next question, which is mention some of the core benefits of DevOps. So the core benefits of DevOps are as follows. First of all, we'll say technical benefits. First, technical benefit of DevOps is continuous software delivery. Then second is less complex problems to manage. Third is early detection and faster correction of defects. Then here comes the business benefits. The first benefit of DevOps, that is business benefit of DevOps, is faster delivery of features. So it allows faster delivery of features. Then there is stable operation environment. Then third one is improved communication and collaboration between the teams. So these were the business benefits. So here we have discussed both technical benefits and business benefits. Alright, now the next question is how will you approach a project that needs to implement DevOps? So here are the simpler terms. Here's how we can bring DevOps into a specific project using these steps. Step 1 would be first, we look at how things are currently done and figure out where we can make them better. This makes about 2 to 3 weeks. Then we can plan for what changes to make. Then step 2 would be we create a small test to show that our plan works. When everyone agrees with it, we can start making the real changes and put the plan into action. Then third step would be we are all set to actually use DevOps. We do things like keeping track of different versions of our work, putting everything together, testing it and making it available to the users. We also watch how it's working to make sure everything goes smoothly. By doing these steps right, the keeping track of changes, putting everything together, testing and watching how it's going, we are all set to use DevOps in our project. So this is how you can approach a project that needs to implement in DevOps. And this is how you can answer this question. Alright, moving on to the question number 7, which is what is the difference between continuous delivery and continuous deployment? Alright, so first would be continuous delivery. So it ensures code can be safely deployed on production, whereas continuous deployment Here, every change that passes the automated test is deployed to production automatically. Then in continuous delivery, it ensures business applications and services functions as expected, whereas in continuous deployment, it makes software development and the release process faster and more robust. In continuous delivery, delivers every change to a production-like environment through rigorous and automated testing. Whereas in continuous deployment, there is no explicit approval from a developer and requires a developed culture of monitoring. So these were the 3 points that you can highlight while differentiating between continuous delivery and continuous deployment. Alright, so this was the question number 7. Now moving on to the question number 8, which is name 3 security mechanisms of Jenkins uses to authenticate users. So here we have to name 3 security mechanisms. First one would be Jenkins uses an internal database to store user data and credentials. Second is Jenkins can use the lightweight directory access protocol, that is LDAP server, to authenticate users. Third one is Jenkins can be configured to employ the authentication mechanism that the deployed application server uses. So these were the 3 mechanisms that Jenkins uses to authenticate users. Alright, now moving on to the question number 9, which is how does continuous monitoring help you maintain the entire architecture of the system? So continuous monitoring within DevOps involves the ongoing identification, detection, and reporting of any anomalies or security risk across the entire system infrastructure. It guarantees the proper functioning of services, applications, and resources on servers. By overseeing server statuses, it accesses the accuracy of application operations. This practice also facilitates uninterrupted audits, transaction scrutiny, and regulated surveillance. So this was about the question number 9, that was how does continuous monitoring help you maintain the entire architecture of the system. Now moving on to the question number 10, which is what is the role of AWS in DevOps? So in the realm of DevOps, AWS assumes several roles. First one would be adaptable services. So it offers adaptable pre-configured services, eliminating the necessity for software installation or configuration. Second one is designed for expansion. Whether managing one instance or expanding to 1,000, AWS services accommodate seamless scalability. Then there is automated operations. AWS empowers task and process automation, freeing up valuable time for inventive pursuits. The next one is enhanced security. AWS Identity and Access Management, that is IAM, allows precise user permissions and policy establishment. Then the last one is extensive partner network. So AWS fosters a vast partner network that integrates with and enhances its service offerings. So these were the role of AWS in the realm of DevOps. Alright, now moving on to the question number 11. Name 3 important DevOps KPIs. The 3 important KPIs are as follows. First one is mean time to failure recovery. This is the average time taken to recover from a failure. Second KPI is deployment frequency. The frequency in which the deployment occurs is called deployment frequency. Third one is percentage of failed deployments. The number of times the deployment fails is called percentage of failed deployments. So these were the 3 important DevOps KPIs. This question can also be asked. Alright, moving on to question number 12, which is how is IAC implemented using AWS? So commence by discussing traditional methods involving scripting commands into files, followed by testing in isolated environments prior to deployment. Notice how this practice is giving way to infrastructure as code IAC. Comparable to code for various services, IAC aided by AWS empowers developers to craft, accesses, and manage infrastructure components descriptively utilizing formats like JSON or YAML. This fosters streamlined development and expeditious implementation of alterations in infrastructure. Alright, now moving on to question number 13, which is describe the branching strategies you have used. They'll ask you this question. So to test our knowledge, the purpose of branching and our experience of branching at a past job, this question is usually asked. So here we will discuss topics that can help you answering this DevOps interview question. So release branching. We can clone the develop branch to create a release branch once it has enough functionality for a release. This branch kicks off the next release cycle, thus no new features can be contributed beyond this point. The things that can be contributed are documentation generation, bug fixing, and other release related tasks. The release is merged into master and given a version number once it is ready to ship. It should also be merged back into the development branch, which may have evolved since the initial release. So this was the first one. Then there is feature branching. This branching model maintains all modifications for a specific feature contained within a branch. The branch gets merged into master once the feature has been completely tested and approved by using tests that are automated. Then the third branching is task branching. In this branching model, every task is implemented in its respective branch. The task key is mentioned in the branch name. We need to simply look at the task key in the branch name to discover which code implements which tasks. So these were the branching strategies that you can say that you have used, or if you have really used it. Otherwise you can say something else. Alright, moving on to question number 14, which is, can you explain the shift left to reduce failure concept in DevOps? So shifting left within the DevOps framework is a concept aimed to enhance security, performance, and related aspects. To illustrate, consider the entity of DevOps processes. Currently, security evaluations occur before the deployment stage. By employing the left shift approach, we can introduce security measures during the earlier development phase, denoted as the left. This integration spans some multiple phases, encompassing pre-development and testing, not confined to development alone. This holistic integration is likely to elevate security measures by identifying vulnerabilities at initial stage, leading to a more fortified overall process. Now moving on to the question number 15, which is, what is blue/green deployment pattern? So this approach involves seamless deployment aimed at minimizing downtime. It entails shifting traffic from one instance to another, requiring the replacement of outdated code and a new version to integrate fresh code. The updated version resides in a green environment, while the older one remains in a blue environment. After modifying the existing version, a new instance is generated from the old one to execute the updated instance, ensuring a smoother transition. So the main focus of this approach is smooth deployment. Alright, so this was question number 15. Now moving on to the question number 16, which is, what is continuous testing? So continuous testing involves the automated execution of tests within the software delivery pipeline, offering immediate insights into potential business risks within the latest release. By seamlessly integrating testing into every stage of the software delivery lifecycle, by seamlessly integrating testing into every stage of software delivery lifecycle, continuous testing minimizes issues during transition phases and empowers development teams and instant feedback. This approach accelerates developer efficiency by obtaining the need to rerun all tests after each update and project rebuild, culminating in notable gains in speed and productivity. So this was about continuous testing. Now moving on to question number 17. What are the benefits of automation testing? So some of the benefits of automation testing includes, first, it helps to save money and time. Second is, unattended execution can be easily done. Third one is, huge test matrices can be easily tested. The next one is, parallel execution is enabled. Then there is reduced human generated errors, which results in improved accuracy. And last one is, repeated test tasks execution is supported. So these are the benefits of automation testing. Coming to question number 18, which is, what is a Docker file used for? So a Docker file is used for creating Docker images using the build command. With a Docker image, any user can run the code to create Docker containers. Once Docker image is built, it's uploaded in Docker registry. From the Docker registry, users can get the Docker image and build new containers whenever they want. So this is what Docker file is used for. Coming to question number 19, which is, what is the process for reverting a commit that has already been pushed and made public? So there are two ways to do that, to revert a commit. So first would be remove or fix the bad file in a new commit and push it to the remote repository. Then commit it to the remote repository using git commit -m commit message. Again, git commit -m commit message. So this is the first way. Then second is create a new commit that undoes all the changes that were made in the bad commit. Then use the command git revert commit id. As you can see in the screen, first command also and the second command also. The second command says git revert commit id. Commit id, you will have to put the commit id. Alright, so question number 19 this was. Now moving on to the last question, which is question number 20. How do you find a list of files that have been changed in a particular commit? So the answer would be, the command to get a list of files that have been changed in a particular commit is git diff tree -r. Then there is commit hash. So this command, as you can see on the screen, git diff tree -r commit hash, you can put it. Then example is also there, like commit hash 87E6735F21B. So this is example as you can see on the screen. Then there is -r flag instruct, so the command to list individual files, and commit hash will list all the files that were changed to or added in that commit. So there's telling about the, as you can see, -r functionality. -r is a flag that instructs the command to list individual files, and commit hash will list all the files that were changed or added in that commit. So these were the top 20 DevOps interview questions that you must understand if you're planning to give a DevOps interview. So in this video, we have explored key concepts, methodologies, and best practices that are crucial in fostering collaboration between development and operations teams. By understanding the principles discussed here, you are well equipped to navigate the dynamic landscape of DevOps. As we wrap this DevOps Crash Course, you have taken a significant step towards mastering the world of DevOps. You have learned the essence of DevOps and its impact on your career with exciting salary prospects. Exploring 9 essential DevOps tools including Git, GitHub, Selenium, Jenkins, Docker, and Kubernetes has equipped you with the valuable skills. Remember, the journey doesn't end here. DevOps is a dynamic field, ever evolving and continuously innovating. So keep exploring, practicing, and embracing new tools and techniques. Good luck on your DevOps adventure.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.